Hello guys, how are you today? I hope that everyone's doing well. So today I'll be explaining like a general revision of mechanics. I'm basically gonna do the required questions for mechanics. So I'm gonna do all of them from the CQD, from the required chapters in the CQD, except for the vectors because they don't have a CQD paper or a CQD file for themselves. So anyways, without further ado, I believe for the vectors, I am only gonna stick to the multiple choice questions. You can find these PDFs on the SDP. I will stick to the multiple choice questions because if I did stay and explain the written questions, which we don't have a written part, so I don't see a need in explaining the written questions, it would take a really long time. So thus, for vectors, I'm only going to be explaining the chapter review multiple choice questions. In total, that is 20 questions for vectors, which I believe is more than enough. Then, after vectors, I'm gonna do the part A chapters, which are chapters, let me get my paper, chapters 1, 2, 3, 4, 5. These are part A chapters. I will be doing, I will combine all of them into a revision. So I will name this video part A, full entire revision mechanics. And I will combine all chapters together so that it will be easy to revise. Okay, so anyways, without further ado, let's get started with the first question. It's saying which of the following is a vector quantity. When they say vector quantity, so what do they mean when they say vector quantity? That they mean when they say vector, it is a quantity that has both direction and magnitude. Okay, direction and magnitude. Now, I do expect this video to be like 3 hours or so, but it's just like a whole entire revision compressed into one video. Of course, I'm only gonna be doing the required section, so for the vectors, it's all the required. So, a vector quantity has both direction and magnitude. If they asked you for something scalar, that means it only has a magnitude. Now, logically speaking, when you are dealing with time, do you say that you have negative time? Do I have minus 5 minutes? That does not make sense. So that means time only has a magnitude. It does not have a direction. You can't go positive, negative time. You can go up, down time. No. Time only has a magnitude. So time is a scalar quantity. Mass. You cannot say this person has a mass of minus 5 kg, for example. This also does not work because mass can only be positive. You cannot have a negative value of mass. So it does not have a direction, so it's also scalar. Here you should know the difference between distance and displacement. Displacement has both a direction and magnitude, so it's a vector quantity. Distance only has a magnitude, so it's a scalar quantity. Force, on the other hand, I have different types of forces. I can have, for example, a regular force, which will have a positive notation, a positive direction, and then a resistive force, such as friction, etc., that have a negative direction. So yes, force is our first vector. Why? Because it has both a magnitude and a direction. Now, last but not least, temperature. So now temperature, when we talk about positive temperature and negative temperature, it is only because it's explaining how hot or cold an object is. Very simply, temperature only depends on the magnitude. You know what I mean? It does not have a direction. You cannot say, my temperature is moving, my temperature is upwards. I have up temperature, I have down temperature. No, you cannot say this. You can't say I have temperature 25 degrees Celsius north. No, that does not make sense. So thus, my temperature is what? My temperature is a scalar, okay? So my only vector in question number 1 would be D, okay? We'll move on to the next question, which is question number 2. What does it say? Which of the following statements are true? They want us to look at the two vectors and look at the options and see which of the following are true. First of all, part A, it says the two vectors are opposite. When we look at the two vectors, we see that they're both going in the same direction. So no, they are not opposite. And then part B, the two vectors are equal. No, looking at them again, they don't have the same length, so they are not equal. Now the two vectors are a scalar multiple of each other. Now, what does it mean for something to be the scalar multiple of another thing? Very simply, two vectors, they are scalar multiple of each other if one of them can be obtained by multiplying the other by a single number, which is a scalar number. You know, you don't have a direction for the number. So yes, this is potentially true. If I multiply v by something, I will get probably u, and if I multiplied u by something, I could end up with v. So yes, this is a potential answer. Now, the two vectors have identical lines of action. When two vectors have identical lines of action, very simply it means that they act along exactly the same straight line. In this case, they are not doing that, so this is the wrong answer. So part E, the two vectors are anti-parallel. What does it mean anti-parallel? They are parallel to each other, but they're going in opposite directions, which is not true. So in this case, the only correct answer would be what? It would be C, okay? So now we'll move on to part 3. What does it say? Which of the following expressions best describes the relation between U and V? So first of all, we look at U and V and we see that they're going in opposite directions. So of course, there needs to be a minus somewhere. Here, this does not contain a minus, so this is not an option. And this does not contain a minus, so this is not an option. The next thing we notice is what? We notice that U is greater than V. What does this mean? This means I had to multiply, let's say it's minus x. Here I had to multiply V by a number greater than 1 in order to end up with U. Are you understanding? So V is smaller than U. I need to multiply V by a number greater than 1 in order to end up with U. So definitely this is out of my options and this is out of my options. So my last option would be option A. Okay, we'll move on now to part 4. What does it say in part 4? It says which diagram shows the correct resultant vector of the two vectors. So how do we draw resultant vectors? First of all, we need to pay attention to something important. I have two vectors and they are not combined together. It's not going to work out like this. First of all, what I need to do is I need to redraw it, right? So this would be U, for example, and this would be V. But I connect them from a point. I either connect them, their head with their head, or their tail with their tail. So tails together or heads together. Here, I found it easier to connect them tail with tail. Now, what do? I apply something called the parallelogram method. What do I do in the parallelogram method? Very simply, I copy, I oppose the parallel vectors. So for example here, I do something like this, right? And on the opposite side, I do something like this. So now look what's happening. I have two intersections. I have two tails together and I have two heads together. So now my resultant would be from my tail to my head. It would end up looking like this. And then I can call this what? I can call this U plus V. Okay, so let me erase these so we can see what our resultant could potentially look like. And I see very clearly that my resultant could look like A, and A is the correct answer. Okay, I didn't even see the other options and I got the correct answer. Okay, let's move on to part question 5. They want which diagram shows the resultant of V minus U. So now we need to pay attention. There's something very important. V minus U. V stays exactly the same, but U, what happens to it? It flips. So now it's gonna be like this, V, and it's gonna be like this. How? It's gonna be like this, U. So what I could do is I could move this over here so I can connect them tails with tail. So now here I have, actually it's like this. Let me draw it more accurately. I have V and U. Then I apply the parallelogram method. So over here this would connect. And over here this would connect as well. So then I end up with here tails and tails. Here I end up heads and heads. And I link it together to end up with something like this. So now, let me draw the head. Please don't forget to draw the head. I'm not sure if it is correct, but I got V minus U to be something like this. So let's see. It's almost, the most appropriate answer for me would be answer C. And let me check the answer key. Yes, this is the correct answer. Okay. Now we'll move on to question number 6. What does it say in question number 6? I and J are unit vectors that are due east and north respectively in a coordinate system. So please remember your coordinate system. Never eat, hold on, let me draw it properly. Never eat shredded wheat. Now remember that north and east are positive, whereas west and south are negative. Now also remember, now for I and J, something important you need to remember. On your y-axis, you have the j vector, right? And on your x-axis, you have what? You have the I vector. Okay, very, very important things to keep in mind. Okay, this diagram will make the whole equation easier. They told us there are points A, which are at 5 centimeters, 2 centimeters, and point B, which are at minus 2 centimeter and 5 centimeters, and they are in the same coordinate plane. Which of the following would give us the notation of U2AB? Now, before we start with our solving, just remember, here you have your x, here you have your y, you have your epsilon, your ordinate, or your ordinate, whatever you want to call it. Now, before we start with anything, let's just label them. So here, for A, I'm gonna have 5i centimeters. Excuse me for the cutoff, so it's gonna be 5i centimeters plus 2j centimeters, all right? And for B, it's gonna be minus 2i centimeters plus 5j centimeters, okay? Now, here's something important. They said they want the vector u from 2ab. Let's ignore 2 for now, we can deal with it later. Let's look at AB. It is from point A to point B, so A is the start, so start is A. B is the end. So, or you can take it as this is the initial and this is the final, okay? So when it comes to solving, I'm dealing with the start and the end. I'm dealing with initial and final. I always need to subtract final minus initial. So what's my final point? My final point is point B. So it's going to be all of the points of B minus all of the points of A. But let's do it in the vector system, okay? So it's gonna be B, which is minus 2i, okay, plus 5j in centimeters, minus what? Minus 5i plus 2j, also in centimeters. So if you solved it, I'd have minus 2i minus 5i, that's minus 7i. So minus 7i. Okay, and then I have plus 5j minus 2j, that's gonna be minus 3j, minus 3j, and they're both multiplied by the centimeter. But now don't forget that we had a 2. If you don't multiply by 2, everything will be ruined. So let's multiply by 2. This is plus, excuse me, I forgot to put the plus. So then, as a final answer, I will get minus 14, minus 14i plus 6j, and all of it is multiplied by what? By centimeters. So my answer is B. Let me check the answer key. Yes, it is the correct answer, so that is it for question number 6, okay? We'll move on to question number 7. What does it tell us? It tells us a force F, which is 2i minus 4j newtons, acts on a moving car. Now they want the magnitude of F, something very important. Whenever they say magnitude and they gave us the vectors over here, we very simply need to do the not roots. We need to apply kind of Pythagorean theorem. Why exactly? For example, let's see what we're dealing with over here. We have 2i, so on my x-axis I have 2, minus 4j, so on my y-axis I have minus 4. Now they want the magnitude. The magnitude, because this is minus 4 and this over here is 2, I know they're not accurate. The magnitude would be what would be the resultant force, which in this case we can apply Pythagorean theorem because it is a right triangle. So very simply, it would just be radical 2 squared plus minus 4 squared. You don't add I or j, why? Because it's a magnitude. So you put it on your calculator, radical 2 squared plus minus 4 squared, and please do not forget the brackets. Put it on your calculator. I got 4.5, and what's my unit? My unit is newtons. So my answer would be C. Let me check. I checked my answer key. Yes, it is C, so we are on the right track, okay? We'll move on now to question number 8. What does it say? Okay, so now we'll move on to question number 8. What does it say? Given two forces, F1 is 3i minus 2j newtons, and F2 is 2i plus 3j newtons. They want the magnitude of the resultant of the two forces to the nearest newton. So now here we have to pay attention to something really extremely important. They are mentioning the magnitude, but now we need to combine the two forces, F1 and F2. We need to get the resultant, so we need to add them together. So we're going to do F1 vector plus F2 vector, okay? We'll combine them together. So basically, you will get 3 plus 2i plus minus 2 plus 3j. So then you'll get 5i plus j. And now we can do Pythagorean theorem on these two values in order to get the resultant of the two forces. So this would be radical 5 squared plus 1 squared. You will get approximately 5.099. So basically 5 newtons to the nearest newton. So D is the correct answer. Let me check my answer key. Yes, D is the correct answer. Okay. We'll move on now to question number 9. What does it say? Very simply, it says, a metal ball is thrown in air. The initial velocity vector of the metal ball has a magnitude of 5 meters per second. So we have the magnitude. The magnitude, I'm going to call it R. It's 5 meters per second. They gave us the angle. It was thrown at us 53 degrees. Okay, here this is very important. Why did I write theta and I didn't continue reading? This is a big mistake because they could have given me bearing. They could have given me anything else. Angle of 53 degrees with the positive sense of the x-axis. So pay attention. Here, it makes an angle of 53 degrees with the positive sense of the x-axis. Whenever it makes an angle with the x-axis, and of course the angle is going to go like this, then I would consider it theta. If it makes my angle starting from the north, then it's called what? It's called a bearing. Okay, so pay attention. Theta is from the positive sense of the x-axis, and the bearing is from the north. Okay, so now they want the vertical and the horizontal components of the velocity vector. So there is an equation you need to know. In order to find the velocity x, for example, or like the x vector, very simply, the equation is gonna be what? It's gonna be v initial, for example, v initial, or like r, cosine theta, and don't forget to add the I if you're dealing with the regular one. And then Vy, it would be what? It would be R sine theta J, okay? Here in this case, they don't want the R and J, and that's fine. It doesn't matter really. So Vx, it would be R cosine theta, so it would be 5 cosine 53. Put it on your calculator, I got 3 meters per second. And then if I did 5 sine 53, so over here I did Vy equals 5 sine 53, I would get an answer of 4 meters per second, and that's it for part E. Sorry, for question 9, it is E. Yes, that is the correct answer, okay? We'll move on now to question number 10. It says, what are the polar coordinates? Exactly, what are the polar coordinates? They're asking us the question before they continue the question. You know, we have a question before we even continue the question. What are the polar coordinates? They're very simply R and theta, where R is the magnitude, okay? And theta is the angle. Alright? So let us find the r of the vector. It's very simply going to be radical minus 3 squared plus 7 squared. So let me put it on my calculator. I got as an answer 7.6, so r is 7.6. And then theta, pay attention on how to calculate theta. The regular equation for finding theta is tangent inverse y over x. Now, we only have one abnormal case where we need to actually do something. You may have minus y over x, you don't need to do anything. Y over x, you don't need to do anything. You may have whatever, y, it doesn't matter if it's plus or minus, but over minus x. As soon as in the denominator you have negative x, to the whole answer you need to add 180 degrees, okay? So for example, in this scenario, it's going to be theta is equal to tangent inverse y, which is 7, over x, which is minus 3. Put it on the calculator, but pay attention. You have minus x, so you need to add 180 degrees. So then you put it on the calculator, and I got an answer of 113 degrees. So the correct answer for question 10 is C, okay? So now we'll move on to question 11. What does it say in question 11? The magnitude and direction from I of the vector v is equal to 6i plus 8j. Okay, now question number 11, they want the magnitude and direction. When they say magnitude and direction, they mean r and theta. So basically, I forgot what they're called, the polar coordinates, okay? So let's find r together. It's going to be radical 6 squared plus 8 squared, so it's going to give me an answer of 10. All right, and now they want theta. Theta is equal to tangent inverse of y over x, 8 over 6, and there's no need to add 180 because my x is positive. So my correct answer for 11 should be A, and yes, it is the correct answer, okay? We'll now move on to question number 12. What does it say? Very simply, it says, point A has a position vector u, okay? it gave me the position vector, which is 10 meters, north 30 degrees east. Okay, so these are the I think Cartesian coordinates? No, I'm not sure. I forgot what they're called, okay? And point B has a position vector, 10 meters and bearing of 240 degrees. They want us to find the expression of AB in terms of I and J. So let's just imagine what's happening over here. Let us draw. Okay, there's always no harm in drawing. It will help you understand better, okay? So I have a vector of 10 meters and it's north 30 degrees east. So here's north, here's east. I will draw my arrow. Always my 30 degrees is gonna be next, like it's gonna be to the one that's in front of it. So north 30 degrees east, I'm gonna have my 30 degrees to be starting from the north direction. If I had east 30 degrees north, I'd have my 30 degrees starting from the east. And this has a position vector of 10 meters, okay? And for point B, so this is point A over here. For point B, it has a position vector V bearing 10 and bearing 240 degrees. Now remember the bearing, we always need to start from the north. So this is 90 degrees. What's 240 minus 90? That's gonna be 150. This is another 90 degrees. So that's minus another 90, that's gonna be 60 degrees. So now I have 60 degrees left. So here I'll come. This all in all is 240 degrees. And this over here, this tiny portion is 30 degrees. How did I know? Because over here I have 60 degrees. Here I have 90, here I have 90. So 60 plus 90 plus 90, that's 240. So that's, I will have what? I will have 300 degrees, 30 degrees in this portion, okay? And this is point B. And this is also 10 meters. They want us to find the expression of AB in terms of I and J. Now, before we proceed with anything, if they want it in terms of I and J, that means I'd need to change A into I and J and B into I and J. First of all, let's change A into something I and J. Okay, I have my magnitude, okay, and I can find out what? I can find out my theta. Very simply, my r is 10 meters and my theta, which is my degrees starting from my angle starting from the positive x-axis, it's gonna be what it's gonna be. If this is 30 degrees, it's gonna be 90 minus 30 degrees, which is 60 degrees. So my theta is 60 degrees. So in order to find the I and J terms for A, oh my goodness, it went down. Let me put it back as it was before without it moving, but it's, of course it needs to move. Let's just try a bit like this. Okay, that worked. All right. So anyways, it would be what? It would be r cosine theta I plus r sine theta j. Okay. So here it would be 10 cosine 60i plus 10 sine 60j. Okay. This is for A. Let's now move on to B. For B, the r is how much? The r is 10 meters and theta is how much? Theta, it's gonna be from my positive x-axis, so it's gonna be 90 degrees plus 90 degrees plus 30 degrees. So that's 90 plus 90 plus 30 degrees. That's all in all 210 degrees. So my theta is 210 degrees. Okay. So again, I need to apply the r cosine theta I plus r sine theta j. So it's gonna be 10 cosine 210 I plus 10 sine 210 j. Okay. So anyways, now what can I do? I can add them together. So it's gonna be 10 cosine 60. So I add I with I. So 10 cosine 60 plus 10 cosine 210. What do I get for my x? I will get minus 3. I think there is a mistake in this question. I do remember solving some of these questions with my teacher and he was like, there are mistakes, so pay attention. Now, excuse me. I was doing something wrong. I just realized what I was doing and what I did wrong. Anyways, look, they want AB. A is the start, B is the end. Here's where I went wrong. I said that you need to add them together. No, don't add them together. You need to subtract them. So you need to do position B minus position A. So that would mean for the cosine, it would be 10 cosine 210 minus 10 cosine 60. What do I get for the I vector? I got minus 13.6j. Okay, minus 13.66j. And then if I did 10 sine 210 minus 10 sine 60, I will get as well, sorry, this is I, excuse me, why did I say J? Excuse me, this is I don't know why I'm a bit lost right now. Minus 13.66J, okay? So this is supposed to be the correct answer. I do remember some of the questions are wrong. Now, they said, what did they say? In the answer key, let me check. Question 12, they said it was D. And I don't think the answer is D, but please do double check with your teacher. I do believe this question is wrong. In the end, I got this as an answer. This is supposed to be your answer based on what we did, okay? That's it for question number 12. We'll now move on to question 13. Given two forces, F1 equals 6i minus 8j and F2 is 3i plus 4j. Find the resultant vector r of F1 and F2 and its direction. So remember, when we have two forces, the first thing we need to do is we need to add them together to find F resultant. It's F1 plus F2. So it's going to be 6 plus 3i plus minus 8 plus 4j. So that's going to be 9i plus minus 4j, okay? So I'll erase this 9i minus 4j. So now we can find the resultant, which is r. So it's going to be radical 9 squared plus minus 4 squared. Please do not forget your brackets. So radical 9 squared plus minus 4 squared, that's going to give me 9.84. Actually, now that I look at the answer options, there is no need to do this. So we know that it's 9i minus 4j, but now they want to find the angle. So let's find theta first of all. Theta is equal to tangent inverse of y over x, so minus 4 over 9. There's no need to add 180 because our x is positive. So I got an angle of minus 23.9 or like minus 23.96 degrees. So basically minus 24 degrees, okay? So if we are gonna draw, minus 24 degrees would be something like this, right? So minus 24 degrees, it's over here, but you don't put minus 24, you put 24 degrees because it's down, okay? Now this is east and this is south. So my angle, it's now east 24 degrees south. So my correct answer would be option E, and for question 13, yes, this is the correct answer, which is option E, okay? We move on now to question number 14. What does it say? Very simply, for question 14, it says I and j are unit vectors that point due east and north respectively. Find the vector of v of magnitude 4 having the same direction as u, which has a magnitude of 2 and a bearing of 210 degrees. They gave us that v is equal to minus ai minus b radical cj, where to the nearest whole number a, b, and c respectively are. Okay, so basically what they're saying over here is we have whatever we're dealing with over here, okay? It has a magnitude of 4 and it has a bearing of 210 degrees. So 180, 210 degrees is somewhat here, okay? 210 degrees. Alright, so if we were to start from here, this would only be 120 degrees because we removed 90. So from here to here, all of this, which is theta, it would be 240 degrees. So we have theta, which is 240 degrees, and we have the magnitude, which is 4. So now, how do we find the vector v? Very simply, in terms of I and j, it's going to be 4 cosine theta I plus 4 sine theta j. Please put it on your calculator. So 4 cosine 240, I got minus 2i. Plus 4 sine 240, I got minus 2 radical 3j. So I already have minus here and minus here. There is no need to include them. So I would put 2 and 2 and then 3. So the correct answer would be option C, which is actually the correct answer, okay? We'll move on now to, they want us to use the given to answer questions 15, 16, and 17. In the square ABCD, M is the midpoint of CD, N is the midpoint of AD. Vectors AB are represented in magnitude and direction by AB and AD respectively. They want us to express CN in terms of A and B. So, excuse me, I hid my taskbar. So they want us to express CN. Pay attention to how they're saying it. CN. So C is the start, N is the ending. C is the tail, and N is the head. we know very simply that this is the midpoint, like here, this is half b. And this is also half b. Alright? Very simply, this is just for you to know, just to pay attention, because n is the midpoint and m is also the midpoint. So, how do I reach from my starting point to my ending point? I need to go C to D, right? And then I need to go how? I need to go D to N. So, that would be what? That would be CD, right? And CD, as you can see, it's going anti-parallel to A. So, it's the same length as A, but it's going in the opposite direction. So, it's going to be minus A, okay? In addition to what? In addition to, now, DN. DN is going through half of B, right? But it's going in the opposite direction of B, so it's going to be minus. So the correct answer should be minus A minus half B. So for 15, the answer should be A, which is the correct answer, okay? So now we'll move on to question 16. They want us to express Mn in terms of A and B. So please pay attention to how it starts. Mn, right? So from M to D and then D to N. From M to D, it's going anti-parallel to A, and it's half of A, so it's gonna be minus half A, right? And then for Dn, we know that it's minus half B, right? So the correct answer should be minus half times A plus B. Okay, so let's see the correct answer. It's minus half A minus half B. So for 15, no, that's 16. 16, the correct answer should be B. And yes, that is correct. We'll now move on to 17. What does it say? It says, express vector AM in terms of A and B. So where is AM? Here's A. Here's M. From A to M. Please try always to find the simplest and easiest way. So from A to D, and then from D to M. From A to D, this is the distance of B, so that's going to be B. And then from D to M, that is parallel to A, not anti-parallel. It's going in the same direction. So from D to M, it's going to be the same direction, but it's half of A. So it's going to be B plus half A. So what's the correct answer here? B plus half A. Is it an option? Yeah, B plus half A. So 17, the answer should be B. Yes, the answer is B. Okay? We'll now move on to question 18. What does it say? Okay, question number 18. They want the magnitude and the direction. They gave us V1 and they gave us R. They want the magnitude and direction as angle of elevation of what? Of R respectively. So for R, we need to substitute V1 and V2. So R would be equal to 3 times V1, so 3 times 5I plus 3J, minus 2 times V2, which is 6I plus 2J, right? So let's expand and solve. That's going to be 15I plus 9J minus 12I minus 4J, okay? So 15 minus 12, that's going to be 3I. 9 minus 4, that is going to be, what is 9 minus 4? That's going to be 5J, okay? So now we can find the magnitude. It's going to be radical 3 squared plus 5 squared, okay? So I got the closest answer to be 5.8. And now pay attention. They want the direction as the angle of elevation. That means they want theta. So theta would be what? It would be shift tangent y, which is 5, over x, which is 3. So I got 59. So theta would be 59 degrees, and r would be what? Would be 5.8. So the correct answer should be E. And looking at my answer key, it is the correct answer, okay? We'll now move on to question 19. What does it say? It says, consider the vector v equals 3I plus 4j. The vector v can be expressed as v equals ku, where k is the magnitude of v, and use a unit vector. Determine the value of k and express the unit vector in terms of I and j. So, when they talk to us about a unit vector, what does a unit vector mean? Very simply, a unit vector, for example, u, it would be the original value divided by the magnitude. Why did I do 3 times 5? Because if you found the magnitude, it would be radical 3 squared plus 4 squared, which is 5. So then it would be 3 over 5i plus 4 over 5j. This immediately is what is my unit vector. So v is k times u. K is always going to be what? It's always going to be the magnitude, which in this case is b. So what is the correct answer? The correct answer is B, and I look at my answer key, it is also B. Now, the last and final question for regarding vectors, what does it say? Vector V below has a magnitude of radical 13 and makes an angle of 135 degrees with the positive x-axis. So this is how much? This is my theta, it is 135 degrees, okay? What is the expression of V in terms of I and J? We have magnitude and we have the theta. So it would be R cosine theta I plus R sine theta J, okay? So it would be radical 13 cosine 135 plus radical 13 sine 135. Put on your calculator. Radical 13 times cosine 135. I got an answer of minus radical 26 over 2i plus then radical 13 times sine 135. I got an answer to be radical 26 over 2j. So my answer would be A, and A is the correct answer. That's it regarding vectors. Thank you guys for watching. I'll see you in the next part of the video, which is the part A, the chapter 1 of the CQD. Hello guys, how are you? So welcome to the second part of the video where I'm gonna be doing the course revision questions. I'm gonna be doing the mechanics AS and A-level course question documents parts 1 and 2. So I'm gonna be explaining the required sections for each chapter. So I finished vectors. Now I'm gonna be explaining chapter 1. So chapter 1 we have from section 1.7 until 1.12. So let's find 1.7. Here we go. Here is 1.7. We're gonna start with grid number 9. What does it say? When a car moves from an asphalt road into a rough dirt patch, its speed decreases from 20 meters per second, this is V initial, to V final 12 meters per second in 2 seconds. This is the time. So they want the average acceleration of the car. Now, something important you need to pay attention to is when they say average, when they say instantaneous. They did not say instantaneous. If they say instantaneous, they would give you an equation and you'd need to derive it to get the acceleration, and then you substitute the time. However, here they want the average acceleration. So whenever they mention average acceleration, you need to find V final. You subtract it from V initial and you divide it by the time. So here it would be 12 minus 20 divided by 2, which is minus 4.0 meters per second squared. So that is it for question number 9. We'll move on to section 1.8, which is question 10. What does it say? The diagram below shows the variation of a subway train's velocity with time. They want the acceleration of the train at time 30 seconds. At time 30 seconds, the acceleration of the train would be the slope of the tangent. Since this line is a straight line, is not a curved line, we find the slope of the line itself and we will get the acceleration of the train. Why did I say it's the slope? Because we're dealing with a velocity time graph. Velocity over time, y over x, rise over run, which is the slope, will give me the acceleration. So here acceleration is the change in velocity divided by the change in time. So let's find the slope here. For example, you can choose 60 and 21 and 0, 0. So then acceleration would be what? It would be 21 minus 0 over 60 minus 0. So you will get approximately 0.35 meters per second squared. So that is the acceleration. Actually, not approximately, you will actually get the exact answer to be 0.35 meters per second squared. Now, in what interval is the magnitude of acceleration of the train the greatest? So we know that the acceleration is what? Is the slope. So basically, the steeper the slope, okay, the greater the acceleration. This is something very, very, very important to keep in mind. The steeper the slope, the greater the acceleration. So looking at the 3 segments, we have this segment, and this segment. This segment is the steepest out of all of them. So this segment would have the greatest magnitude. Keyword is magnitude. Pay attention. It matters if it's positive or negative, but they want magnitude. Okay, so the steeper the slope, then the greater the acceleration in terms of magnitude, okay? So now we'll move on to question 11. What does it say? It says the diagram below shows the variation of a cyclist's velocity with time. Explain how to calculate the instantaneous acceleration of the cyclist at time equal 10 seconds. So we don't need to calculate it, we just need to explain. Very simply, what we're gonna do is we're gonna draw a line tangent to the curve, which is shown in the graph, at which time specifically, at time being 10 seconds. Then you draw the tangent. My tangent's not going to be so accurate, but it's something like this. Then you draw a right triangle, so it will turn out something like this, for example. And then you're going to find the acceleration by doing rise over run, or you will find the slope. So again, how do you calculate? You draw a tangent at the specific time. You draw a right triangle where the tangent is the hypotenuse, and then you find the acceleration by doing rise over run, or basically you find the slope. Okay, that's it for question 11. We'll now move on to question 12. What does it say? The velocity time graph of a particle is shown below. Calculate the average acceleration of the particle between time 2 seconds and time 5 seconds. Remember, we said average acceleration is velocity final minus velocity initial divided by the change in time. So average acceleration is equal to change in velocity over change in time. Now we have to be precise with the values. This is 25.5, and at 2 it's approximately 4. So 4, or no, why did I do it the opposite way? Excuse me. It's 5.25. It's x then y. I don't know why I said 25.5. And then again I did the same thing. 2, 4. Okay. So now what do? We're supposed to draw a secant, not a tangent, because it passes through 2 points of the curve. Okay. And then you find the slope of this. I know it's not that accurate. I can't draw a straight line on my tablet, but it's fine. Anyways, what do we do now? We substitute the values. So it's going to be 25 minus 4 over 5 minus 2. So 21 over 3, which is 7 meters per second squared. We move on to question 13. What does it say in question 13? Why is the velocity time graph of a body moving in UARM linear? So VT graph. What is the slope of the VT graph? It is the acceleration, right? Now, UARM means we have a constant acceleration. If we have a constant acceleration, that means our slope is constant. If our slope is constant, then we get what? We get a linear function. Okay, that's it for question 13. We'll move on to question 14. Does a positive acceleration always mean that the body is speeding up? Not necessarily. A positive, you need to understand this. You need to separate into velocity and acceleration. You need to know, is it speeding up? SU means speeding up, and SD means slowing down. It's speeding up if my velocity and acceleration have the same sign. So it's either plus, plus, or minus, minus. It's slowing down if my velocity and acceleration have opposite signs. So it's plus, minus, or minus, plus. So how do I know if my body is speeding up? First of all, if it has a positive acceleration, it's going to be speeding up if it's moving with a positive velocity, right? Or if it's moving in the positive direction. However, very important, if it's moving in the opposite direction with a negative velocity, then the body is gonna be slowing down. Okay, this is something very important you need to keep in mind. So now we'll move on to question 15. What does it say? It says, consider the velocity time graph below of a particle. The instantaneous acceleration of the particle at time 5 is a5. So where's time 5? a5. And the instantaneous acceleration, here you need to draw the tangent. It's already a straight line. So you find the slope of the line and you will get a5. And then at time 7, it's what? It's a7. Okay? Now, they want us to compare the magnitudes, very important, of these accelerations. Now, remember what we said. We said the steeper the slope, the greater the acceleration. So, in magnitude-wise, of course. So, this has a steeper slope, magnitude-wise. So, thus, it has a greater acceleration, again, magnitude-wise. So, a7 is going to be greater than a5. Okay, that's it for question 15. We'll now move on to section 1.9, question 16. What does it say? At 1 p.m., a car is spotted traveling at a constant velocity of 25 meters per second towards a street sign 2,000 meters away. Determine the equation of motion of a car. So, we have the car over here. It's going towards where? Towards a street sign. We call this SS. Now, let's say this is the origin. Always assume where you are going to is the origin, okay? Now, At 1 p.m., here at 1 p.m., a car is spotted traveling with a constant velocity of 25 meters per second. They told us velocity. That means it's plus 25 meters per second, okay? Now, the distance between the car and the stop sign was 2,000 meters. So, for the car to be able to reach the stop sign, it needs to travel how much? It needs to travel 2,000 meters. But it's not going an additional 2,000 meters. It's going back to the origin. So we're going minus 2,000 meters. Okay? So now we need to apply the equation. So x, it's going to be equal to what? It's equal to vt plus x initial if you want. So x final, which is going to be for us x, because we want to find the equation of motion, is equal to the velocity, which is 25 times the time, which is not specified, plus x initial. If I'm starting here at 0, here it will be minus 2,000 meters because it's to the left. So, oh, excuse me, I don't know where I went. Yeah, I went all the way down. Let me go back to where we were. Okay, it was probably here. Excuse me for this, by the way. I really do apologize. But I don't want to get rid of the, oh my goodness. Let me erase these. Okay, you're gonna have to, 1 second. Okay, so I managed to return. Anyways, so plus x initial, which is how much? Which is minus 2,000 meters. This is all I needed to add before it went down. So anyways, I'm going to move on to section 1.10, which we're going to have 17 grid. The diagram below shows the variation a cyclist's velocity with time. What is the total displacement of the cyclist? Now pay attention, whether they say in the exam displacement or distance. The total displacement, you need to put the values positive and negative. Alright, and you add all of the areas together, no matter their sign, you're keeping the sign the same, you're not changing it, and you're adding it together, okay? But if they ask for distance, you need to put everything in absolute value and you need to add them together, okay? So, the total displacement of the cyclist in 20 seconds. How do we find the displacement on a VT graph? We need to find the area. Here we're dealing with a trapezoid, so it's gonna be base 1 plus base 2 times the height over 2, which is the area of a trapezoid. So base 1, it's from 5 to 15, which is 10, plus base 2, which is 20, times the height, which is 6 divided by 2. So it's basically 30 times 3, which is 90, yeah, which is 90 meters, okay? That's it for question 17 grid. We'll now move on to 1.11, motion with constant acceleration. I'm gonna do I'm gonna do all of the questions. I'm not gonna miss anything. So the last question I'm actually gonna be doing is question 24, because they did not specify any questions, but they did not tell us not to do any questions, so I'm gonna do everything. So question number 18, what does it say? A toy car initially moving in the positive direction, very important, the positive direction at 0.50 meters per second, so this is the initial. At time equals 0, the car accelerates for 0.20 meters per second, so this is our acceleration for 6 seconds, and this is the time. They want the displacement of the car. Displacement is denoted by delta x. Also position? No, position is not denoted by delta x. Position is denoted by x, but displacement is denoted by delta x. And what's the equation? If I have my acceleration, my time, and v initial, delta x is going to be equal to 1 over 2 at squared plus v0t. Now, why do I not add x initial? Because delta x is x final minus x initial. So what do we do now? We put it on the calculator. Delta x is equal to 1 over 2 times 0.20 times 6 squared plus 0.50 times 6. You put it on your calculator and you will get 6.6 meters, and that is the displacement of the car. So now we'll move on to question 19. Look what it says. It says, the position of a particle moving along the x-axis is given by the equation x equals 3t minus 2t squared. So this is the position with x, okay? They said determine the characteristics of motion of the particle. Looking at it, look what I can see. I see my position x equals, I have t squared. That means they use the equation 1 over 2 at squared plus v0t. First of all, when I see that I have t squared, I can immediately know that I am dealing with UARM, so uniformly accelerated rectilinear motion. So my motion is uniformly accelerating, it's rectilinear, and the equation of motion is x equal 1 over 2 at squared plus 0t plus x initial. Why? Because I did not write delta x, I wrote x, okay? Very, very important. That's it for part A. We didn't really, oh yeah, actually we do need to go into more detail. They might ask you what is the acceleration. You need to determine the characteristics of that. Excuse me, I needed to move this. So my acceleration it's going to be 1 over 2 at squared. It's going to be equal to what? It's going to be equal to minus 2t squared. V0t, it's going to be equal to what? It's going to be equal to 3t. And x initial, there's nothing. So x initial is what? It's 0, okay? So what does this mean? This means that my V0 is equal to 3. And over here, it means that my acceleration, it's equal to minus 4. Very simply, just like that, we solved and we got the value of the acceleration. We got V initial, we got x initial. We found that it's UARM and it's a rectilinear motion. So that's it for part A. Part B, what does it say? It says determine the velocity at time equal 3 seconds. So it's the velocity at a specific time, specific instant. So we need to derive in order to get the velocity. So let's derive this equation. It's going to turn into V equals 3 minus 4t. So now we need to substitute the time as 3 seconds. So it's going to be 3 minus 4 times 3, which is minus 9 meters per second. Now, part C. Determine the average velocity. What did they ask for? Average velocity. Average velocity is the displacement over the change in time. So, what do I need to do? I need to substitute these into this equation over here. I get x final and x initial. I find delta x, and then I divide it by the change in time. So x final, sorry, I'm going to take this space down, is equal to 2 times 6 squared, or sorry, let me put it in order. 3 times 6 minus 2 times 6 squared, let me put it on my calculator. I got minus 54. And then x initial, it's 3 times 2 minus 2 times 2 squared. So 3 times 2 minus 2 times 2 squared, that's going to be minus 2. So x initial is minus 2. So minus 54 minus 2 divided by the change in time, which is 6 minus 2. So minus 52 divided by 4. I think that's 13. Yeah. So minus 13. So the average velocity between the times 2 seconds and 6 seconds is minus 13 meters per second, okay? When we finished question 19, we'll now move on to question 20. What does it say? It says a car is moving at a constant speed of 30 meters per second along a horizontal and straight road, where the speed limit is 80 kilometers per hour. All right. We then have a police officer on his motorcycle who spots the speedy car and starts chasing it 2 seconds after the car passed him. Find the distance covered by the car before it gets caught by the police officer, given that the motorcycle accelerated from rest at 6 meters per second squared. Take the origin of time and space at the same point where the speeding car passes the police officer. So we have a car moving at a constant speed, right? So the car is moving in URM. So the position of the car, we're going to call it XC. It's going to be equal to what? To the velocity of the car times the time plus X initial of the car times what? Times the, just X initial of the car, okay? So we know that it starts from where? It starts from, let's assume it starts from position being 0. So x, it's gonna be what? X, it's gonna be x of the car, it's gonna be 30 times the time, okay? Now, what do they need after this? Now they need the motorcycle of the police. Since the police is accelerating, we have UARM. So the equation we're gonna be using is x of the motorcycle. It's 1 over 2 at squared plus v0m, which is the initial speed of the motorcycle, times the time plus x initial m. Alright, so xm would be equal to what? It would be equal to 1 over 2 times 6, so that's going to be 3 t squared, plus v initial. They told us that the motorcycle accelerated from rest, so v initial is 0. This is t, by the way, plus x initial. What is x initial of the motorcycle? We're going to assume that he is he's starting from position 0. But now we have, we have a small issue in between the time. They don't both start at the same time. When the car starts moving, it starts at a time t. But when the motorcycle starts moving, it starts moving with a 2-second delay after the car passes. So it moves at time minus 2 seconds. And of course, it's always going to be squared. Okay, so now I have the equation of position of the motorcycle and the equation of position of the car. Now, for them to meet, okay, they need to be equal to each other. So 30t must be equal to 3t minus 2 squared. So then 3 and 30 cancel. I'll have 10t is equal to t minus 2 squared. let me put the time. So let us expand it. We will get 10t is equal to t squared minus 2 times 2, that's 4 times t, 4t plus 4. Okay? So then you'll move this to the other side. You will get 0 is equal to t squared minus 14t plus 4. Put it on your calculator as mode 5-3. So mode 5-3, we have 1 minus 14 and 4. So I get two possible answers. The first possible answer is 13.7 seconds, and the second possible answer is 0.29 seconds. But how is this possible if there's a 2-second delay? How do they meet at the 0.29 seconds? Yes, actually they do meet. They do come at the same time. They're both at the same position, but then the car continues on. It passes. When it passes the motorcycle, there's a point where they're at the same position. So it passes the motorcycle, and then later the motorcycle will catch up to it, which is not so this is not what we're looking for. We're looking for the time when the motorcycle catches up with it, which is the 13.7 seconds. Now, are we done yet? No. They want us to find the distance covered by the car before it's caught by the police officer. So we know it travels 13.7 seconds. For both of them, they have the same time. So to find the position of the car, I'm going to substitute it over here. So it's going to be 30 times 13.7, which is actually exactly 411 meters. So it travels a distance of 411 meters before being caught. Okay, that's it for question 20. Now we'll move on to question 21. What does it say? A train moving along a straight track accelerates from rest. That means v initial is equal to 0 at 2 meters per second squared. This is our acceleration for 20 seconds. This is the time. It then moves at a constant speed. So now, initially it was UARM. Now it turns into URM for 120 seconds. So this is the time. Finally, the train decelerates. So now again, it's UARM uniformly to stop. So v final is equal to 0 in 40 seconds. This is our time. They want us to write the equation of motion of the train in each phase. So we have phase 1. It accelerates from rest. They want the equation of motion. So x final is equal to what? It's equal to, we have acceleration, v initial, we have time. And of course, x initial is 0 because it's starting from the origin. So it's going to be 1 over 2, 80 squared. What's the acceleration? It is 2. So 1 over 2 times 2, that is 1. T squared plus v0, which is 0, times the time, plus x initial, which is 0. So I get 1t squared. However, they gave us the time, so I'm going to substitute it. So it's going to be 1 times 20 squared, which is 400 meters. Okay, that's it for the first phase of motion. The second phase of motion, it's a new RM. So they want x final. It's going to be v times t, right? Velocity times time plus x initial. So x final is equal to the velocity. What is the velocity? It's moving at a constant speed. So excuse me, it moved up a bit. Here we need to play it very smart. They want the speed. It's moving at a constant speed, and initially in the first phase it accelerated from rest. So we have acceleration, okay? We have delta x, we also have the time. So we might be able to find v final. Very simply, v final is equal to acceleration times time plus v initial, right? So v final is equal to 20 times 2 plus 0. So v final is equal to 40 meters per second. So this is my velocity, my new velocity, or my speed, okay, which is 40, times the time, which is 120 seconds, plus x initial, which was 400 meters. Please do not forget about this. X initial is not from the initial. It's from where we stopped, or where we're starting, which is the 400 meters. So 40 times 120 plus 400, I got 5,200 meters. Okay, now for the third and final stage of motion, the train decelerates uniformly. So v initial was 40 meters per second. It comes to a stop. V final is 0 meters per second. The time is 40 seconds. They want the position, the equation of motion. So here we need to apply x final equals 1 over 2 at squared plus v0t plus x initial. So now here we don't have the acceleration. How do we find the acceleration? We use our given. We'll do v final minus v initial over time. So it's going to be 0 minus 40 over 40, which is minus 1 meter per second squared. So now it's going to be 1 over 2 times 1 times the time. What was the time given to us? 40 seconds squared, plus v initial, which was 40, times the time, which is also 40, plus x initial, which was what? Which was 5,200. Excuse me, I don't know where I disappeared to. I'll go back up after this. So then, it's gonna be what? It's gonna be 1 over 2 times 1 times 40 squared plus 40 times 40 plus 5,200. I got... Actually, you know what? My equation might be wrong. Hold on, let's try to go up. However, we do have a small problem here that I forgot to mention. It's decelerating, so my acceleration was negative, right? And I forgot to put the -1. So please pay attention to this, or else your whole entire equation would go wrong. So here I got my x final to be 6,000 meters, okay? So now in general, we know how to solve and to get these equations. Now they want us to find the position of the train at time equal 5 seconds, at time equal 60 seconds, and time equal 160 seconds. So at time equal 5 seconds, right? This would be during the first stage of motion. In the first stage of motion, what was our equation? It was 1 over 2 x equals 1 over 2 at squared plus v0t plus x initial, right? X initial is 0. It starts from an s, so this is 0. So it's 1 over 2 at squared. So it's going to be what? It's going to be 1 over 2 times 2 times 5 squared. So it's going to be 25 meters, all right? Now, in the second stage of motion, for the 60 seconds, which is between the 20 seconds and the 120 seconds, the equation that we got, it was that x is equal to velocity times time plus x initial. Now, this applies to what we got initially. X equals the velocity. What was the velocity that we had found? I think it was 40. Yes, we found it to be 40. 40 times the time, which is 60 seconds, plus x initial. What was x initial before? Remember, what was our equation? It was plus 400 meters. The only thing that should change is the time. Everything else is the same in the equation. So here it would be 40 times 60 plus 400. I got it to be... oh, sorry, excuse me. I have a small problem. Wait. The time is actually not 60 seconds. Here, what's the duration of the period is not actually 60 seconds. It's actually 60 minus 20 seconds, because 60 seconds is when they want us to calculate the position, but 20 seconds in between 60 and 20 seconds, because 20 seconds is when the first phase of motion ends, okay, until the 60 seconds, which is where they want us to get it from. This is where the traveling is actually happening. So 40 times 60 minus 20 plus 400. So that's basically 40 times 40 plus 400. I got an answer of 2,000 meters. And now last but not least, the final position. We got it to be minus half. I remember. Minus half times the time. They want it to be 160 seconds, but please pay attention. When does the second phase of motion end? It ends after 20 seconds plus 120 seconds. So imagine, it's accelerating like this, and then it's constant for 120 seconds, and then it's decelerating again. So here, this is 20 seconds, then all of this is 120, so 140 seconds, and then we have an additional 40 seconds, so 180 seconds. So they want the position of the train at 160 seconds. So what was the equation we found up? It was 1 over 2 times -1 times t squared. So basically -1 over 2 times the time. What's the time though? It's from 160 seconds, and it's in between 160 seconds and 140 seconds. So basically 20 seconds squared plus the velocity, which was 40. Velocity initial times the time, which is 20 seconds, in addition to the initial displacement. Do you remember what the initial displacement, or like the initial position was? It was 5,200. So you put it on your calculator and you should get an answer of 5,800 meters, okay? That's it for question 21 and 1.11. And now we reach the last section of chapter 1, which is 1.12 free fall. Okay, question 22 grid. An object released from rest several meters above the ground moves at a constant acceleration. When it moves at a constant acceleration, that means... continue. In the absence of air resistance. Now, this means that it's in what? It's in free fall. That means the acceleration is equal to g in this scenario, and only in this scenario when we have an absence of air resistance. So the numerical value of this acceleration is going to be 9.8 meters per second squared. Now, 23, describe the apparatus used to experimentally determine the acceleration of free fall. First of all, we need a steel ball. This is going to be our subject that's going to drop, okay? And we're going to calculate its acceleration of free fall. We need an electromagnet. Okay, I'll just list all of the apparatus and I'll explain what happens. We need a steel ball, electromagnet, trapdoor, an electronic timer connected to the electromagnet and the trapdoor, and the ruler to measure the distance between the electromagnet and the trapdoor. So basically, we have the steel ball. It's in, like, the electromagnet is on. It will attract the steel ball. So the steel ball is on the top of the electromagnet, okay? We have the trapdoor in the bottom. And we have an electronic timer that's connected to the electromagnet. So as soon as we turn off the electromagnet, the timer stops. And also it's connected to the trapdoor. So as soon as the ball hits the trapdoor, it will stop timing. So like this, with all of this process, we would have gotten the time, okay? Now, how does this help us? We will get the time. We know x initial, it's gonna be 0, right? We can actually find the displacement. No need for x initial. We know that delta x, it's 1 over 2 at squared plus v0t. It's not moving initially. It's released from rest. So v0t disappears, and now we're left with this. Now, how do you determine the delta x? It's very simply from the ruler. You measure the distance. You have delta x. You have the time. You can now find your acceleration. There you go. Very simple, very easy, okay? Now, it's most accurate, of course, to do it with the proper apparatus that was mentioned. So now here, I'm gonna assume that you know the next chapter, because this is a general revision, okay? I'm not explaining this concept for the first time, it's a general revision, okay? A boy standing near the edge of a rooftop, using a slingshot, he shoots a pebble from a point located 45 meters above ground level. So, the height of the building is 45 meters, right? The pebble leaves the slingshot with an initial velocity v0, which is equal to 24 meters per second, directed almost vertically upward. That means theta is how much? Theta is 90 degrees. It moves up, reaches its highest point, and goes all the way down to the ground, barely missing the rooftop. The figure below illustrates the situation. Neglect friction and use g as 10 meters per second squared. So you should know that acceleration on the y-axis, it's minus g, so it's gonna be minus 10 meters per second squared. Right? Now, the velocity, you should know this equation from before. It is minus gt plus v0. This is a preparation for the next section, for the next chapter, actually, because we finished all of the sections of this question. Okay? So v final is minus gt plus v0. Okay? And the delta y, which is the displacement, it's minus 1 over 2 gt squared plus v0. Oh, of course, here it's sine theta because it's on the y-axis. So v0 sine theta. And of course, v final squared minus v initial squared is equal to minus 2. Why do I do minus 2g delta y? Very simply because it's 2a delta x. V final squared minus v initial squared is 2a delta x, but a is minus g, so it's minus 2g delta x. But here we're not on the x-axis, we're on the y-axis. So minus 2g delta y. Let me go up, excuse me. Okay, after 15 minutes, I finally got it in place. So Vy in this scenario, it would be minus 10 times the time. What's the time? We don't have the time. So minus 10t plus V initial, which was 24. Why do I not do sine theta? Because theta is 90 and sine 90 is 1. So there's really no point in it because it's like vertically upwards, okay? Now, delta y, it would be minus 1 over 2 times 10. So that's minus 5t squared. Plus v0 sine theta t, please don't forget the t, excuse me. Plus 24t. And then here, what would I get? I have velocity final. Do I have velocity final? No, I don't have velocity final. So velocity final squared minus velocity initial squared, which is 24 squared. It's going to be equal to what? It's going to be equal to minus 2 times 10, so minus 20 times delta y, okay? So what do they want on part A? They want determine with respect to ground level the maximum height reached by the pebble and calculate the time it takes to reach that point. Now, actually, there's so many ways to do this. I'm gonna use the equations. I said this. You guys should know the equations. I'm gonna do this as a general recap. So imagine this is a preparation for the next section, okay? So to determine the maximum height, we need to use the H max equation, which is what? Which is V0 squared sine squared theta over 2g. So it's gonna be 24 squared sine 90 squared over 2 times 10. So you put it on your calculator, and I got an answer of 28.8 meters, okay? Now, for part B, what do they want? They want us to find the time when the pebble passes by the initial position where it was shot and determine its speed at that instant. So here, we don't have a specific equation. What we need to do is something very important. They want us to find the time when the pebble passes by the initial position. That means what's the displacement? Like here, it travels from here to here. So the displacement is actually how much? It's actually 0. So delta y would be 0. So 0 is equal to minus 5t squared plus 24t. You put it on your calculator, mod 5, 3, minus 5t squared plus 24 and 0. You get the first time to be 4.8 seconds and the second time to be 0 seconds. 0 seconds, excuse me. Okay, 0 seconds is at this point over here. And then at this point over here, what do we have? We have the other time, which is the 4.8 seconds. Okay, for part B, I think there was another part in part A that I missed. Determine with respect to the maximum height and the time it takes to reach that point. So excuse me, I forgot to calculate the time it takes to reach that point. So to find the time it reaches at, like, the time it takes to reach that point, we need to use the another equation if you want, or if you want to use this equation, which is very simple and very easy. You take the displacement, delta y would be 28.8. So 28.8 would be equal to minus 5t squared plus 24t. So you'll move this to the other side and you put on your calculator, mod 5, 3, minus 5, 24 minus 28.8. You will get only one time. You'll get only one value of x to be what? To be 2.4 seconds. Okay, excuse me for ignoring that. And then in part B, we have also a second part as well, which is to find the and determine the speed at that instant. Now, to determine the speed at a specific instant, we need to use this equation. So Vy would be equal to minus 10 times the time. What was the time we found at this position over here? It was 4.8 seconds. So minus 10 times 4.8 plus 24. So then we get minus 24 meters per second. So we can deduce that it has the same speed, but it's going in opposite directions, so it has opposite velocity. Okay, excuse me again for ignoring the second part in part A. Now, part C, find the instance when the pebble is 10 meters above the shooting point and 10 meters below it. So we need the 10 meters above and 10 meters below. That means delta y is either plus 10 or minus 10. Let's start. If it was plus 10, it would be 10 equals minus 5t squared plus 24t. You can move this to the other side, and then you do mod 5, 3 on your calculator. You will have minus 5t squared plus 24 minus 10. On your calculator, you will get one specific time. Actually, no, you'll get two specific times for this one. Why? Because there's two possible places for it to be 10 meters. For example, here, 10 meters, and here, 10 meters. So you might get 4.34 seconds, or you might get 0.46 seconds. Either way, it's possible. Now, if I said it's 10 meters below, so that would be minus 10, okay, because it's going down. So minus 10 equals minus 5t squared plus 24t. So you do mod 5, 3. So then it's minus 5t squared plus 24 plus 10 because you moved it to the other side. And you get one value of x to be positive and one to be negative. Of course, you're going to reject the negative because you can't have negative time. So then time here would be what it would be, 5.19 seconds. So when it is at the 10 meters above the shooting point, it has two possible values, which is either 0.461 or 0.46 and 4.34 seconds. And then if it's 10 meters down, there's two values, 5.19 or minus 0.386. You can't take a negative time. You can't have a negative time. So you're going to stick with the 5.19 seconds. Okay, that's it for part C. Now we'll move on to part D. Find the speed of the pebble as it hits the ground and calculate the time it takes to get there. So they want us to find the speed of the pebble as it hits the ground. So here we need to use V final squared minus V initial squared equals minus 2g delta y. As it hits the ground, it would have traveled the whole height of the building, but because it's going down, it's going to be negative. So minus 45 meters, right? G, we said it was 10, so minus 20. V initial, it was what? 24 meters squared. So now I'll move this to the other side. I will get V final squared. So V final squared, it's minus 20 times minus 45 plus 24 squared. Whatever answer you get, you put it in the radical. And I got what? I got that V final is equal to plus or minus 38.4 meters per second. Now, because it's going down, it's taking, they said somewhere that as he shoots it up, yeah. I forgot where they said that it's positive. Let me continue reading 1 second. I forgot where they mentioned that when you're throwing it up, it's in the positive direction. So when it's falling down, it's going in the negative direction. So my velocity is what? My velocity is gonna end up being negative, right? So I have my velocity now. They want us to find the time. So I can apply this equation over here. Vy equals minus gt plus v0. So minus 38.4 equals minus 10 times the time plus v0, which is what? Which is 24. So move this to the other side. Minus 38.4 minus 24. Then divided by 10, I got the time to be 6.24. Sorry, divided by minus 10, I got the time to be 6.24 seconds. And that's it for chapter 1 from 1.7 until 1.12. So I'm gonna stop the video here, and then I'm gonna add it to the chain of videos, and then I'm gonna continue with chapter 2. Hello guys, how are you today? I hope everyone's doing well. So today I'll be explaining chapter 2 motion in 2 and 3 dimensions. We only have 2.3 and 2.4. These are the only course revision questions we have. I'm not gonna be doing any top questions, so I'm only gonna be doing grid and regular questions. Top questions, I won't be doing them. Or actually, you know what? I don't mind doing them. I changed my mind. I'm gonna be doing the top questions as well. So anyways, before we start, I want to start with a general brief summary about this chapter. So first of all, we have two types of motion when it comes to what we're dealing with. What we're dealing with is called projectile motion. What does it mean, projectile motion? That means you start from a point and you shoot something with a velocity at an angle. And then it will go like this, and then it will fall like this, right? Okay? So this has two types of motion. It has a horizontal motion, which is motion based on the x-axis, and it has vertical motion, which is motion based on the y-axis. All right. So let me start with the horizontal motion and the vertical motion. So starting off with the horizontal motion, you should know that the acceleration on the x-axis is always 0. Okay. The velocity on the x-axis does not change. You should remember that the velocity on the x-axis always stays constant, okay? And the equation to find the velocity on the x-axis, it's v0 cosine theta, all right? Now, how do we find the displacement, which is delta x? It's very simply gonna be velocity x times the time, or in expanded form, it's gonna be v0 cosine theta times the time t. Now, when it comes to vertical motion, what happens? We have the acceleration on the y-axis. Now, always remember, acceleration on the y-axis is always negative g. Why is it minus g? G is an acceleration it occurs downwards, right? But when I'm throwing my object, I'm throwing it in an upwards direction, so it accelerates upwards. So my acceleration would be what would be minus g. So it's basically minus 9.8 meters per second squared. Now, how do we find the velocity on y? Velocity on the y-axis does not stay constant. It's not like velocity x. Velocity y varies based on the time. The equation in order to find velocity y, it is minus gt plus v0 sine theta. Okay? Now, because our velocity y varies and changes with time, we are not gonna do the same thing as we did to find the displacement on the x-axis. Instead, the displacement on the y-axis, it's gonna be using a different formula. Why? Very simply, here we did not have an acceleration, so the movement was URM. There is no acceleration, so URM. So I use the equation delta x equals velocity times time. But here I do have an acceleration. It's u, a, r, m. So I cannot use delta x equals velocity, velocity times time. Instead, I need to use minus 1 over 2, not minus 1 over 2, 1 over 2 at squared. So delta y is 1 over 2 at squared plus v0t. But pay attention, here my acceleration was minus g, so equals minus 1 over 2 gt squared plus v0, in this case it's v0 sine theta t. So far these are the few equations that we need to know of. Now, they may ask you to find a few things. Some examples would be to find the maximum height. What is the maximum height? From its name, it's the highest point that the object reaches, which is this point over here. So we call this h max, and the equation for h max, it is what? It is v0 squared sine squared theta over 2g. Now they may ask you, how far does the object travel? Not how high, how far. This is called the maximum range. So we call this range max, right? It's from here till here. How far? What's the maximum distance? Pay attention, it's different than delta x. What's the maximum distance from start to end that the object travels from? And the equation for this is v0 squared sine 2 theta. Pay attention, not sine squared theta, sine 2 theta over g. Let me just fixate this a bit. Okay, now this is for the maximum range. Now, let's say they asked you to find the time it took to reach the maximum range. Very simply, you have a simple formula. So time R max, I'm gonna call it time R max. So the time to reach the maximum range, it's very simply 2 v0 sine theta over g. Okay? But if they asked me for the time to reach h max, so th max, very simply, it's going to be half the time that it takes to travel the full range. So it's going to be 2 v0 sine theta over g divided by 2, which turns into what, which turns into which equation? It turns into v0 sine theta over g. Alright, I forgot to label here that this over here is v0. Now, let's say they asked you for something different. Let's say they asked you for the speed. Where can I fit this? I'll fit it over here. When they ask you for the speed, what you need to do is you need to take Vy and Vx and you need to apply Pythagorean theorem. Why? Because my speed, for example, at this point, my velocity is upwards and my velocity x is like this. It's always constant velocity. But then, to find the resultant speed, it would be like this. So I apply the parallelogram theorem. So basically I need to find the resultant using Pythagorean theorem in order to get the speed. So speed would be radical Vy squared plus Vx squared. Now, all of these equations lead us to one final equation, which is the projectile equation. It's a very simple equation. I'm going to write it at the top. Very simply, what does it say? Very simply, it is y, okay, the position y, it's equal to minus g over 2v0 squared cosine squared theta. And this is all what? This is all x squared. So all of it is like in the x squared plus tangent theta x. Very, very, very important. This over here is the final equation, which is the projectile equation, which if you substitute anything, you can literally find everything, you know? So basically, this is like a quick brief recap and summary of the chapter. There is nothing left to explain. So without further ado, let's get started with grid number 1. Let's see what it says. 1 grid. A cannonball is launched at 37 degrees. This is our theta above the ground with an initial speed of 25 meters per second. So this is V0. Assume that drag is negligible and take G to be 9.8 meters per second. So acceleration Y is going to be minus 9.8 meters per second squared because AY is minus G. What does it say in part A? In part A, it says calculate the greatest height the ball attains. When they say greatest height, they are referring to H max, okay? H max. So H max, its equation was V0 squared sine squared theta over 2G. So we basically just need to substitute. V0 is what? It's 25. So 25 squared sine squared theta, and the theta in this case was 37 degrees, okay? over 2 times GG is 9.8 in this case. So on your calculator, 25 squared times sine 37 squared. You can't do sine squared theta on your calculator, so you do sine angle and you square it, divided by 2 times 9.8. I got an answer which is approximately 11.5 meters. So the highest displacement, or the greatest height that the ball attains, is 11.5 meters. They want now the smallest speed of the ball as it moves through the air. Okay, now this is actually a very important statement. At some point in time, Vy is going to have a velocity of 0. And when is this velocity going to be 0? When it is at the top, right? The velocity y, pay attention, I'm saying y, it's going to be 0 when it reaches the top of the projectile motion. However, we still have a velocity which is Vx. Vx still exists even though Vy does not exist. Why? Vy doesn't exist because it stops moving up, but it's still moving, for example, to the right. You know, so Vy ceases to exist, but Vx continues existing. So the smallest speed would not be 0, pay attention, it would be the speed of Vx, and we know Vx is equal to V0 cosine theta. So what is V0? It's 25 cosine 37, put it on your calculator. So I got an approximate answer of 20 meters per second. So the smallest possible speed is 20 meters per second. Now they want the range of the ball. What is the equation of the range? The range equation, or the maximum range equation, it is what? It is V0 squared sine 2 theta over G. Did I put 2G in the original equation? Please forgive me. I forgot what I had written. I'm not sure, but this is the correct equation, okay? So anyways, if you substitute, it's gonna be 25 squared sine 2 times 37 over 9.8. So put it on your calculator. 25 squared times sine 2 times 37. Okay, both 2 and 37 need to be inside the brackets. Okay, divided by 9.8. I got an answer of 61.3 meters. So the maximum x displacement, or the maximum range, is 61.3 meters. Okay, that's it for question number 1. We'll now move on to question number 2. What does it say? The diagram below shows the projectile motion followed by a cannon shell. Assume the upward direction as the positive direction. What are they asking from us? They are saying graph the horizontal displacement x and the vertical displacement y with time. Okay, the horizontal displacement. The horizontal displacement, it's gonna be xt, right? Yes. So basically, if you look at the projectile motion, it's moving like this, and at the same time, it's also moving like this, because it's like changing. It's moving from the left to the right. So it has a continuous motion on the x-axis, so it will be a straight line passing through the origin. Now, if they want us to draw yt, right? So basically, how does it move on the y scale? First, it goes up, 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 then it starts going down, like it stops, like it goes up but at a slower rate, and then suddenly it goes down. So the displacement with time of the y axis looks like this. Okay, now we'll move on to part B. It says graph the horizontal and vertical components of the shell's velocity with time. Okay, so let me just erase these. They want the horizontal and vertical components of the shell's velocity with time. We have very simply, let's say it's like this, or no, actually, like this. We have here our velocity, here we have our time. You should know that the velocity of x is constant because Vx is equal to V0 cosine theta. So it's gonna be a constant value. This over here is what? This over here is Vx. But when it comes to Vy, what's the equation? It's minus gt plus V0 sine theta. So this is very important. It starts at a certain position. They both start at the same velocity, which is not really the same velocity, but just like, let's say for example here. And then, look, pay attention. This is a linear graph. We have Vy, which is the final answer, is minus g times t. T is the variable, so that means that minus g is what? Minus g is the slope, and then we have V0 sine theta. which is the y-intercept. So it starts at a certain position, v0 sine theta, and it has a negative value. So it's gonna decrease. So it's gonna look something like this. This is vy, okay? That's it for part B. Now part C, what does it say? How does the magnitude of acceleration of the shell vary with time? So we know that acceleration at x, it's 0 meters per second, but acceleration at y, it's minus 9.8 meters per second squared. They want the magnitude of the acceleration. The magnitude of the acceleration stays constant within time. So they want the magnitude, pay attention. So the magnitude would remain 9.8 meters per second squared with time as it changes. Okay, so that's it for question number 2. We'll now move on to question 3. What does it say? It says compare the ranges of a projectile shot with the same initial speed. So they have both of them, the three of them, v0. But this one has a theta of 30 degrees, this one has a theta of 50 degrees, and this one has a theta of 70 degrees. All right, you could go through the trouble and you could go find R max, maximum range, and you can substitute the equation and whatever, or you could play it smart. If you tried on your calculator, for example, I'm going to give you V0 as 30 meters per second, okay? And we know that the maximum angle it can go to, so theta maximum is what is 90 degrees. Take half of theta max. Theta half max is how much? Is 45 degrees. Now compare, put on your calculator to find the maximum range. So it's going to be 30 squared times sine 90 times 2 divided by g, which is 9.8, I got 0. So when my theta maximum is 90 degrees, then my range is what? My range is equal to 0. So this is the minimum range. But what if I halved it? What if I put, instead of 90 degrees, I put 45 degrees? So sine 45 times 2 instead of sine 90 times 2. So now it's 30 squared times sine 45 times 2 over 9.8. I got 91.8. Now, why exactly did I take half and not, for example, I divided it by 3, I divided it by whatever? Why did I take half? Because very simply, whenever your theta is 45 degrees or half of the maximum, okay, angle, which is 90 degrees, so whenever theta is 45 degrees, it will give you the maximum range, right? So instead of comparing the three values, what we could do is we could take 45 degrees as the maximum range. And we see which one is closest to 45. Then which one is farthest from 45, for example. You know? So let's put them in order. We have 30 degrees, 45 degrees, 50 degrees, and 70 degrees. Okay? So from 30 to 45 degrees, that is 15 degrees. From 45 to 50, that is 5 degrees. From 45 to 70, let me do it on my calculator, 70 minus 45, that is 25 degrees. So the greater the farther the degree is from 45, which is the maximum, the smaller its range is gonna be. So thus, I can say the one with the smallest difference is 50 degrees. So it's the range of 50 degrees is greater than the range of 30 degrees, which is greater than the range of 70 degrees. And every time you do this, you are always going to get the correct answer. Just remember that the maximum is at 45 degrees and the minimum is at 90 degrees. And also at 0 degrees. Okay, so that's it for question number 3. We'll now move on to question number 4. It says a rock is launched from the ground at 10 meters per second at an angle of, so this is V0 and this is theta 53 degrees with the horizontal. They gave us G to be 10 meters per second squared. So here they want the time that the rock is airborne. Here in this scenario, a rocket is launched from the ground and then it will fall all the way to the ground. What do they mean what do they mean by the time that the rocket is airborne? They mean the time that the rocket is in the air. So basically the time that the rocket, from the start, which is 0 seconds, until the end. So they want to find how long it takes for the rocket to touch the ground. So here, there's many ways to do it. I could use this way, for example, delta y equals minus 1 over 2 gt squared plus v0 sine theta t, right? And I can find the time. my delta y is gonna be 0 in this scenario only. Why? Because it starts on the ground, it ends in the ground. So my delta y displacement is 0. But if I threw it from the top of a building and it fell under the building, then my delta y displacement is not 0. It's the height of the building, right? So 0 equals minus 1 over 2 times 10 times t squared plus v0, which is 10 sine 53t. Okay, and then you solve on your calculator mod 5 3 for the value of t, and you can get it to be 1.6 seconds. You'll also get another value which is 0, but 0 is from where it starts. That's why, like, it's another option. Now, another way to do this, only in this scenario, because it starts from the ground, it ends in the ground, not that it's going down a building, okay? We can use t range, right? What's the value of t range? It was 2v0 sine theta over g, I believe. So you put it on your calculator, 2 times 10 times sine 53 over 10, and you will also get an answer which is what? Which is 1.6 seconds, okay? So that is it for part A. We'll now move on to part B. They want the horizontal distance that the rock travels and the maximum height that the rock reaches. So the horizontal distance is the range, right? So you can do this in two ways. Since you already found the time that the rock is airborne, you can find the horizontal distance by doing what? By doing that x is equal to v0 cosine theta t, and then you substitute v0, theta, and t, which is 1.6 we found previously, and you will get an answer which is 9.6. Or you can use the maximum range equation. Why? Because the maximum range is the horizontal distance that it travels from the time that it starts to the time that it is on the ground, okay? What is the equation for the maximum range? It is v0 squared sine 2 theta over g. So it's gonna be what? It's gonna be 10 squared times sine 2 times 53 divided by g, which is 10. So I got also the same answer to be 9.6 meters. Now, how do you find the maximum height? To find the maximum height, this is you can do this in two ways as well. You can find delta y, and then you can actually, no, you can't use delta y unless they give you the time. Yes, actually, you can use delta y. Delta y is minus half gt squared plus v0 sine theta t. Now, here time would be what? In this scenario, we have the total time that the rock is airborne, which is 1.6 seconds. So from here to here, 1.6 seconds. Here would be half of it. So that would be what? That would be 0.8 seconds. And you substitute 0.8 and you're going to get what as an answer? You're going to get 3.2 meters. Or you can use H max, right? The equation for H max is v0 squared sine squared theta over 2g. So it's going to be 10 squared times sine 53 squared over 2 times g, which is what? Which is 10. So you put it on your calculator, you will also get 3.2 meters, okay? Now, part D, what did they say? They said, assuming the initial speed of the block remains the same, or the speed of the rock remains the same, at what angle with the horizontal? Okay, here we discussed this. Here you have to pay attention to your angle. So remember the equations for each of these and discuss the angle. For maximum height, it's sine theta squared. It's v0 squared sine squared theta over 2g. Longest time airborne, it is 2v0 sine theta over g. Maximum range, it's what? It's v0 squared sine 2 theta over g. So we don't care about anything else. The only thing we really care about is what is the thing that's with the angle. So we don't really care about these. We care about sine squared theta, sine theta, and sine 2 theta. So always, the maximum possibility for theta could be what? Could be 90. So here we can ignore sine. We get theta to be 90 degrees. We can also ignore sine. We get theta to be 90 degrees. But here when we ignore sine, we have 2 theta. So 2 theta is 90 degrees. So theta is 45 degrees. So the angle that it should make with the horizontal here is 90 degrees. Here is 90 degrees, but here it should be 45 degrees to reach the maximum range. Okay, so that's it for question number 4. We'll now move on to question number 5. You know, actually, I believe I have solved them in my previous videos, like each separate chapter video. This is a general summary and we don't have a written part, so I don't see a need in solving the top questions. So I'm not gonna do them. I'm just gonna move on directly to section 2.4 because as well I need to make the video as short as possible. I believe like the whole entire video is gonna be around I was assuming it was gonna be like 3 hours. I think it's gonna be like longer, maybe 5 hours or so. So anyways, we'll move on to section 2.4. Section 2.4, I will do the top question because it's only one question that's grid and then a top question, so it's fine. This is the only exception. Okay, section 2.4, 7 grid, what does it say? We have a motorboat moving in a river at 6 meters per second due north, so 6 meters per second north. The river is then flowing, so this is the motorboat. The river is flowing at 2 meters per second due east. What is the speed of the motorboat relative to a stationary observer on the shore? Let's say this is our shore over here. Then the speed of the motorboat would be the resultant of the north and east one. So we apply the parallelogram method if you want. So here and here, we'll end up with this. So now we need to apply Pythagorean theorem. So then it's going to be 2 radical 2 squared plus 6 squared. Oh, sorry, excuse me. So radical 2 squared plus 6 squared. This gave me an answer of 6.3 meters per second. Okay, so because they asked for the speed, you need to do velocity on y squared plus velocity on x squared, and you do radical. Okay, now question number 8 top, what does it say? Very simply, it says define relative velocity. You should know that the relative velocity, let's say we have two objects, A and B. Let's say we're taking the relative velocity of object A. The relative velocity of an object A relative to an observer B is the velocity of A measured in the rest frame of B. This is the answer keys. This is how you say it. So basically, if B is at rest and I see A is moving, then the relative velocity of A to stationary observer B is the velocity that we're talking about, you know? So relative velocity is when you're comparing the velocity of something compared to a stationary observer, okay? This is what they're trying to say from what they wrote in the answer key, okay? We'll move on to part B. What does it say? It says a drone is flying horizontally on a windy day. Figure below shows the velocity vectors to scale for the wind and drone flying in still air. So look what they gave us. They gave us the velocity vectors. Here we have velocity x, here we have velocity y, but we should resolve it. I always do prefer to resolve it. So here we can separate this into the y component and the x component. So this would be vy and this is also vx, okay? So then you could do this in two ways. You could take this angle over here, or you could take this angle over here. I always prefer to take the angle from the positive x-axis. So it would be 90 minus 37, which is 53 degrees, all right? So now let's see what it says. It says 10 meters per second due west, all right? And the velocity of the wind is 4 meters per second in the direction of 37 degrees east of north. So it was here 4 meters per second. So now they said complete the diagram to show the magnitude of the resulting vector. Oh, you could do this in another way. Okay. You know what I'm gonna do? I'm gonna solve part 2 first, all right? Because I do it in a different way than how they did it, and then I'm gonna do part I, okay? Let's start first of all with part I, determine the magnitude. First of all, you need to resolve, okay? So let's resolve the velocities. First of all, 4 meters per second, 53. I want to find Vx. I need to do, because the angle is adjacent to the x-axis, I can then say that Vx, it's equal to what? It's equal to 4 cosine 53 degrees. No need to actually write the full answer. Vy then, it would be what? If 53 degrees is opposite, right? If you draw like a parallel vector of Vy, you will see that the 53 degrees, the angle is opposite. So I'll use sine. So here it will be 4 sine 53 degrees. So then, on my x-axis, I'm going to have 10 minus 4 cosine 53 squared, right? And then on my y-axis, I'm going to have 4 sine 53. Oh, sorry, why did I say squared? Excuse me. It's 10 minus 4 cosine 53 degrees. And then 4 sine 53 degrees. Now, to find the magnitude, I need to do Pythagorean theorem. Basically, I square them and add them, and then I do radical for both of them. So on your calculator, 10 minus 4 cosine 53 squared plus 4 sine 53 squared. Please, here you have to pay attention to the brackets as well. Put it on your calculator and then do radical answer, and I got an answer of 8.2 meters, which is 8.2 meters per second, which is the correct answer. Now, for part I, they want us to complete the diagram to show the vector representing the resultant velocity. Here you need to apply the parallelogram method, so I'm gonna try to mimic it as much as possible. So it would be like this, all right? Then what do? Then this one I will mimic it as well, so it's like this, kind of. So now what do? I connect the tail with the tail and the head with the head. So then it ends up going how? It ends up going like this. So my resultant vector would look something like this. It should look something like this, okay? So that's it for the chapter. Thank you guys for watching this part. Now, in the next video, it's chapter 3. We have 3.5 to 3.8. So let me just check how many questions we have. So 3.5, 3.6, 3.7, and did I miss 3.8? Yeah, here's 3.8. We don't have a 3.9. So until here, this is what this is, 3.8, okay? So thank you guys for watching and see you in the next video. Hello guys, how are you? So welcome back to chapter 3 of the explanation. So this is section 3.5, Newton's second law of motion. I'm gonna start, so for chapter 3 actually we have 3.5 to 3.8. So I'm gonna see which of the following I think are essential to do. So I'm gonna do all questions, but for top questions I'm gonna see which one I must, like, it's better to do and which one is not needed to do, okay? So let's start with question number 11, which is a grid. A car of mass 800 kg, so this is the mass of the car, decelerates or can decelerate from 20 meters per second, so this is V initial, to 0 meters per second, V final, and the time being 4 seconds. They want us to calculate the force applied by the car's brakes. So we know Newton's second law of motion, it is what? It is the sum of forces is equal to the mass times the acceleration. So the only force acting on the car, so imagine this is the car, right? So the car has a weight, but there's also the normal push of the surface. But now there is the force exerted by the brakes, right? This is the only force that is actually causing the car to decelerate. So we will say that F equals ma. The force applied by the brakes is equal to the mass of the car multiplied by the acceleration. How do we find the acceleration? Acceleration is equal to V final minus V initial over time. So it's equal to 0 minus 20 over 4, so minus 5 meter per second squared. So the force is 800 times minus 5 meter per second squared. So the force, I got it to be minus 4,000 newtons, and that's it for question number 11. We'll move on to question number 12. It says define inertia and relate it to the mass of an object. So inertia, what is inertia exactly? Inertia, it's the tendency of an object in motion to stay in motion and an object at rest to stay at rest unless an unbalanced force acts upon it and causes its speed or direction to change. So again, inertia, if they ask you what it is, it's the tendency of objects in motion to stay in motion and objects at rest to stay at rest unless an unbalanced force causes its speed or its direction to change. Now, what is the mass of an object? The mass is the quantitative measure of inertia. Okay, I'm gonna go ahead a few chapters to the most recent chapters we were taking. We took about torque, that the net torque, all right, it's equal to the moment of inertia multiplied by the angular acceleration. How did they get this exact equation? It's very simply the force is equal to mass times acceleration. So now you have to think of things in an angular point of view. Force, the angular force is the torque, because what does the torque do? It's the rotational force, you know what I mean? And acceleration will turn into angular acceleration. But then mass and moment of inertia, this is the moment of inertia. So both mass and moment of inertia, they are both what? They're quantitative measures of inertia. So that's why the mass, if it was in the angular sense, it would turn into the moment of inertia. Okay, that's it for question 12. Let's move on to question 13. What does it say? The trolley in the figure below accelerates, so this is the acceleration, at 2 meters per second squared when the weight of the hanging mass is 4 newtons. So the weight of the hanging mass is how much? Is 4 newtons. So we have an acceleration, I believe the acceleration would be downwards, of 2 meters per second squared. They want us to calculate the inertial mass of the trolley and the gravitational mass of the trolley. So let us assume that the pulley does not have any weight or any friction, or like it has nothing to do with this. It's just there. In this scenario, look what happens. The tension that this pulls the weight, it's gonna be it's gonna be the same as the tension that pulls the trolley. But now we have to pay attention. If we read, we will understand clearly what's happening. Is the weight accelerating? They did not mention the weight accelerating. They said the hanging weight. That means it's just existing over here. It's just existing, but what's actually accelerating is the trolley. So acceleration equals 2 meters per second squared. So now, look. So now, what would if the block is hanging, okay? It's not moving. That means sigma Fy, excuse me, I erased it. That means sigma Fy is gonna be equal to 0. That means the weight minus the tension is equal to 0. That means the weight is equal to the tension. That means if my weight is 4 newtons, then my tension is also 4 newtons. And we said that this tension here, it's the same as this tension here. So this is also going to be 4 newtons. So now they want us to find the inertial mass and the gravitational mass. So far, based on every experiment that scientists and physicists have done, they have found out that the gravitational mass and the inertial mass are equal. But what's actually the difference between one and the other? The inertial mass, it actually measures how much an object resists acceleration when a force is applied, which is F equals ma, whereas the gravitational mass, it's actually the measure of how strongly an object interacts with the gravitational field, which is Fg equals mg, right? So basically, F equals ma is the same as Fg equals mg, and let's say this is mass inertial and this is mass gravitational, right? And since all objects fall with the same acceleration if we ignore air resistance, then this and this cancel. The forces are the same, so thus we get that the inertial mass is equal to the gravitational mass. So let us first of all find the either mass, and we will get the answer. So sigma F is equal to ma. So 4 is equal to the mass times the acceleration, which is 2, so the mass is going to be equal to 2 kg. So both the gravitational and inertial mass of the trolley are equal to 2 kg. Okay, that's it for question 13. We'll now move on to question 14 in section 3.6. Question number 14, what does it say? A person walking with a speed of 0.9 meter per second, so this is the initial, applies a force of 500 newtons on the ground. What is the magnitude of the force exerted by the ground on the person? Now pay attention, they want magnitude, so it would be the same exact force. Here, this is Newton's third law. For every action, there is a reaction of equal magnitude but opposite direction. So the person walking on the ground would exert a force of 500 newtons on the ground, and then the ground would exert a force in magnitude 500 newtons on the person. So, for example, if you hit the table, then the table will also hit you back. You know, this is action and reaction. And please pay attention to when they say magnitude and when they don't mention magnitude, because once it will be 500 and another time it's going to be minus 500 if they remove the magnitude, okay? We'll move on now to question 15. It's saying a rocket is propelled by hot gases pushed out of it. The graph below shows how the force by gases on a rocket varies with time. Plot the variation exerted by the rocket on the gases. So this is the gases on rocket. Now they want rocket on gases. So it's gonna be force F time T, okay, and it's gonna be the opposite of the graph. So what does it mean? Same exact time, but we're gonna flip the graph, so it's gonna look something like this. So what did we do? We flipped the graph. Why? Because it's an action and reaction, equal magnitude, opposite direction, okay? So now we'll move on to section 3.7, which is friction. Okay, friction is the most important part, and they only have 2 questions, but that's good. We will be able to solve the 2 questions, okay? 3 wooden boxes are placed on 3 different floors and are pulled with a horizontal forces, 3 different ones, F1, F2, and F3, respectively. All 3 boxes remain at rest. What does this mean? Very, very important condition. If they remain at rest, okay, we'll come back to this later, but are on the brink of moving. What does it mean they are on the brink of moving? So actually, we have 2 types of friction. We have the static friction and we have the kinetic friction. When an object is at rest but is on the brink of moving, for example, I'm gonna take my water bottle over here. I'm gonna push it, like it's not move, it's at rest, but it's almost about to move. Okay, this is static friction. I am pushing my bottle, but then there is what? There is the friction that is also resisting my force, okay? And these two balance out, so my bottle remains at rest, but it's on the brink of moving, it's on the verge of moving. But then if I apply stronger force, my bottle will eventually move. When my bottle eventually moves, my friction will become less than my force, so then it will turn into kinetic friction, okay? So they want us to find the frictional forces of each box respectively. There is some very important equation you need to know, which is that frictional force, small f we're gonna call it, small f, it's equal to mu, which is the coefficient of friction multiplied by the normal force. This is something very important that you must know and you must remember. So F1, okay, it's equal to mu, we'll call this mu1, times the normal push. What's the normal push? The normal push would be equal to the weight in this scenario only. Why? Because it's not, it's on a flat horizontal surface. And the box is stationary on the y-axis. So times the normal push, which is my weight, which is 1 kg times g. Okay? So let me call this N1. Okay? So frictional force 1, we know that all three boxes remain at rest. What does this mean? This means that sigma fx is equal to 0. That means F1 is equal to small f1. That means 10, okay? Oh, actually, excuse me, they want us to compare the coefficients, not find the forces of friction. Okay, they want us to compare the coefficients. So it's going to be 10 is equal to coefficient 1 times the normal push 1, which is what? Which is 1 times g, we're going to say, for example. So mu1, it's equal to 10 over g. All right, now what if we did for F2? F2, it would be equal to mu2 times N2. So F2, we know it's 2 newtons because they're at rest, okay? It's equal to mu2 times N2, and N2, it's going to be the mass, which is 3 times g. So mu2 is equal to 2 over 3 g, okay? And then, last but not least, we have F3. F3 is equal to mu3 times N3. So it's going to be 5 is equal to mu3 times 2g. So mu3 is equal to 5 over 2g. Please pay attention where you place the g. G is in the denominator. So if we were to compare them, we will see that mu1 has a greater coefficient than mu3, and mu3 is greater coefficient than mu2, very simply, okay? How did I compare them? I used this one and this one and this one. That's it for question 16. We'll move on to question 17. What does it say? Into what form of energy does friction convert the energy of motion? So basically they're saying, friction, when you have friction, right? What does it do with the energy of motion? It turns it into thermal energy. Very simply. Into thermal energy, or you can say into heat energy, both of them work. So now we'll move on to section 3.8. We have 18 and 19 and 20. And then that's it for this chapter. We're done with chapter 3. So now we have section 3.8. Question number 18. What does it say? Two blocks are connected by string S2 as shown below. The upper block is pulled upward by another string S1. The masses of the upper and lower blocks are respectively mass 1 being 200 grams and mass 2 being 400 grams. Okay, that means mass 2, it's gonna be 0.4 times g, which is 10, so that's 4 newtons. And mass 1, it's gonna be 0.2 times g. Why did I do 0.4 and 0.2? Because I divided them by 1,000. You can't deal with grams in physics, you need to deal with kilograms. So then 0.2 times 10, that's gonna be 2 newtons. They said the rope will break if tension exceeds 5 newtons for S2, and the rope S1 will break if tension exceeds 10 newtons. So now they want us to calculate the tensions in strings S1 and S2 when the blocks are in equilibrium. When the blocks are in equilibrium, then sigma Fy is going to be equal to 0. What does this mean? This means the force of tension of S2, right, would be the same as the block mass 2. But now we have something important. Here in this system, we have not only the force of the weight of block mass 1, but we also have tension 2, because this has this rope over here, it's tension 2. But we also have tension 2 acting on string 1. So string 1, which has tension 1, it would be what? It would be carrying both the weight of 2 newtons and the tension 2. So now, because it's an equilibrium, that means sigma Fy is equal to 0. Here in this case, that means tension 1 is equal to weight of block 1 plus tension 2. And tension 2 would be equal to weight of block 2. That means tension 2 is equal to 4 newtons. And tension 1 is equal to weight of block 2, which is 2 plus 4 newtons, which is in total 6 newtons. So tension 1 is 6 newtons and tension 2 is 4 newtons. Now, determine the largest acceleration the system can be given without either rope breaking. So let me again, this is 4 newtons, this is 2 newtons, right? Now we have acceleration, so we cannot assume that sigma Fy is equal to 0. Now it's equal to ma. So let us re-add our equations. Now, we have this tension 2 over here, and we have this tension 1 over here, and don't forget as well, there's the tension 2 over here that's acting on the string, okay? So, look what happened. Let us start with the simplest and easiest one, which is tension 2. Now, without either rope breaking, we cannot go downwards, because if the rope, if we go downwards, it doesn't make sense because it's attached, I believe, to the roof, for example. So let's assume it goes up. So that would mean that tension 2 is stronger than 4 newtons. So we'd have to do tension 2 minus the weight. So the tension minus the weight, okay, it would be equal to the mass of block 2, which is 0.4 kg times the acceleration, right? Now, here's a very, very important part when it comes to tension 1, right? So tension 1, it's pulling everything up. So it's stronger than the weight and it's stronger than tension 2. So tension 1, we will subtract it from what? From the weight of mass 1, which is 2 newtons, in addition to tension 2. So then we will have 0.6 A, right? Oh, excuse me, I did not... I misput the weight. Excuse me. Here the weight is not 0.6, it's 0.2. Why? Because we're only dealing with the block mass 1, even though it's also carrying mass 2, but we replaced it with what? We replaced it with tension 2. So basically what we did now was we separated the two systems. We did this system for the lower block and this system for the upper block. So now let's find a possible acceleration. What I could do is I could distribute the minus first of all. So minus 2 newtons minus tension 2. Then I can add these two equations together. So I'll end up with T1 minus 4 newtons minus 2 newtons is equal to 0.6 acceleration because this and this cancel out. Okay, so then T1 maximum, the maximum force we can get is 10 newtons for tension 1. So tension 1 minus 6, it's equal to 0.6 acceleration. So I got 4 is equal to 0.6 acceleration. One possible acceleration is 6.67 meters per second square. But, however, if I substituted this acceleration in the tension 2 equation, let's find out the value of tension 2. I get 0.4 times 6.67, and then I move the minus 4 to the other side, that turns into plus 4. I get a value that my tension 2 is 6.67 newtons, which is greater than 5 newtons. So string 2 is gonna break, which is not what we need. So we need to find another solution. So we found a possible acceleration, but it only works for tension 1, so we're gonna reject it. Instead, what we're gonna do is we're gonna try focusing on on tension 2. So that would be what? That would be we would substitute the 5 newtons over here. So 5 newtons minus 4 newtons is equal to 0.4 A. So then acceleration is 1 over 0.4, which is 2.5 meters per second squared. And if you substituted it in this equation over here, okay, that means, first of all, tension 2 is going to be 5. So tension 1 minus 2 newtons minus tension 2, which we said it's going to be 5 newtons, is equal to 0.2 times 2.5. Now move these to the other side. I got 0.2 times 2.5 plus 5 plus 2. I got tension 1 to be 7.5. It's less than 10 newtons, so yes, this works. That means the greatest acceleration my system can have is 2.5 meters per second squared, okay? Now we'll move on to question 19. What does it say? A block of mass m is placed over a plank of mass capital M. The coefficient of friction between the block and the plank is mu, and the surface on which the plank is placed is smooth. The plank is pulled horizontally to the right with a constant force F as shown below. They want the free body diagram. So look, I'm going to start with the block. The block has a mass of what? It has a mass of mg. It has a frictional force, because imagine, try this activity at home. Take a book if you want. I'm going to take a book right now. I'm going to place my water bottle. Take an empty water bottle and look what you're going to do. You're going to drag your book. Wait, hold on. That's not going to work. We need something. I need more space. But basically, place your empty water bottle on the edge and then drag your book. You will see that your water bottle moves to the opposite direction. So if I dragged my book to the right, my water bottle was moving to the left. Actually, it's not moving, okay? It's maintaining its inertia. Because it was at rest, then I put an unbalanced force, and then it maintained its inertia, so thus it was moving. And not really moving, but it was moving. So there is a friction, but the friction, it's going in this direction. Because how's my block moving? My block's moving like this, right? So friction, and then we have the normal push. Now, for the other body, which is the plank, all right, here this is very important. Please pay attention. We have the mass, okay, which is mg, and here we have as well the normal push of the block, because it's surface to surface. There is a normal push. I'm gonna call this n prime, which is the other direction, not the normal push of the plank on the block. No, it's the normal push of the block on the plank. Then we have the surface exerting a normal push on the plank. We have the force F, and now this is very important. There is a friction over here. There is another friction over here that's of equal magnitude but opposite direction. This is something very important to pay attention to. So that's part one done. They want us to derive an expression for the acceleration of the block relative to the ground. We know that there's going to be acceleration. So sigma Fy is equal to 0 because the block's not moving up and down. But sigma Fx is equal to ma because the block is moving left and right. So then, this would mean that my friction F is equal to ma, but I know that my friction F is equal to mu times the normal push. The normal push in this case is m times g. So mu mg is equal to ma. I cancel here, I get my acceleration is mu g. So that is part B done. I'm going to erase these and I'm going to put the final answer, which is A equals mu g. Now, part C, what do they want? They want us to derive an expression for the acceleration of the plank relative to the ground. So here sigma Fx is equal to ma, sigma Fy is equal to 0. So F minus friction is equal to capital M. Please pay attention, it's capital M, not small m. My friction, F minus mu mg equals capital M times A. So F minus mu mg, capital F, minus mu mg over capital M is equal to the acceleration. So that's it for part C. Part D, it says take M to be 2 kg, capital M 10 kg, mu is 0.10, F is 20, and the length of the plank is 6.4. They want the time, okay, after which the block loses contact with the plank. So basically, when the block loses contact with the plank, it would have gone through the whole length of the plank. So what we need to do is we need to do delta x is equal to 1 over 2 at squared plus v0t. Well, delta x is the length of the plank, which is 6.4, but now the acceleration is very important. It's going to be the acceleration of the plank relative to that of the block, so ap minus ab. So I'm here, if you substitute the values, for the plank it's going to be 20 minus 0.1 times 2 times 10 over 10, I got an answer of 1.8, minus if the acceleration of a block, if you do 0.1 times 10, it's 1, so you get 0.8 meters per second squared. So now this is my acceleration over here, but it starts from less, so there's nothing over here, so the time will end up becoming what? If you solve it, it will end up becoming 4 seconds, okay? So now that's it for part D. We'll now move on to part C. If the surface on which the plank is placed was rough, so now there's going to be additional friction. Okay, how would the time found in part D change? Very simply, we know that the additional friction that is directed leftwards on the plank, it will decrease the acceleration of the plank. If the acceleration of the plank decreases, then the relative acceleration decreases. So then what would happen? My time would increase then in solving. So my time increases So yeah, my time increases. That's it. That's my answer. Okay, so again, I'll explain. I have more friction, a greater force of friction, right? So it will decrease the acceleration of the plank. This will then decrease the relative acceleration, which would increase the time that the block travels before they separate. Okay, that's it for question 19. We'll move on to question 20. It's only 2 parts, and then that's it for chapter 3. An outwood machine is made of 2 blocks of masses 50 grams and 300 grams connected by a light and extensible string passing through the groove of a massless and frictionless pulley. The heavier block is placed on a smooth inclined plane at an angle of 37 degrees with the horizontal. They said calculate the acceleration of each block. So here what we need to do is we need to separate them. First of all, this block, we know that it has a weight. The weight, it's gonna be 50 over 1,000, which is the mass, times g, which is 9.8. So it's gonna be 0.49 newtons, and it has a tension, which we will call it T. This tension is the exact same tension over here, right? So now pay attention. The mass that we're gonna be dealing with, it goes down like this, right? So we need to end up resolving it. When we resolve it, you should know that on my x-axis it turns in wx, and on my y-axis it turns into wy. And don't forget, of course, there is the normal push as well. So wy, very simply, it's gonna be m. Here, let's call this capital M, and m at 0.3. So 0.3 times cosine 37. Yeah, times cosine 37 times g. And here it will be wx 0.3 times sine 37 times g, which is 9.8. So 0.3 times sine 37 times 9.8. It gave me what as an answer over here? Over here, it's 1.7 newtons, all right? So now we need to pay attention on the acceleration. Here, my weight is greater than my weight here. So now my acceleration, it's gonna be in this direction, right? So I'm gonna start with this system over here and then this system over here. Here my weight is stronger, so it's gonna be my weight minus my tension. It's equal to the mass of the block, which is 0.3 times the acceleration. Here, my tension is stronger than my weight, so my tension minus my weight, which is 0.49, it's equal to what? It's equal to the mass of the block, which is 0.05 times the acceleration A. But actually, if you want to get the exact values, the exact answers, you'll put 0.3 times sine 37 times 9.8 on your calculator. So please don't round. If you want to get the exact answers, you need to put the exact values, okay? So then you need to add these two equations together. Tension and tension cancel. I have 0.3 times sine 37 times 9.8, okay? And then I will subtract from it 0.49. So then I get my answer. Keep your answer exactly as it is. It's equal to 0.35a because I added them together. Then I divide my answer by 0.35. I got my acceleration to be 3.66 meters per second squared, okay? So now, they said in part B, calculate the tension in the string. The tension in both strings is going to be exactly the same. So this is 3.66. Because the same string is working on both of them. So you just choose whichever one you want. For example, I can choose tension minus 0.49 is equal to 0.05 acceleration. So 0.05 times 3.66, okay? Then I'll move 0.9 to the other side. 0.49 to the other side. So plus 0.49, I got my tension to be approximately 0.67 newtons. Okay, that's it for question 20. And that's it for chapter 3. Thank you guys for watching and see you in the next video. Hello guys, how are you? And welcome back to the fourth chapter, chapter 4, work, energy, and power. We have 4.1, 4.2, 4.3, and I also think 4.4, yeah, and then we don't have 4.5, we have 4.6. So I'm not gonna be doing the top questions because they already have a lot of questions and we don't have any written part. Okay, so we have section 4.1, work done by a force. Okay, the work done by a force, its equation is usually force times distance times cosine theta. Okay, so let's get started with the number 1. A 40 Newton box slides through a 10 meter along a frictionless inclined plane. So here we go. Let's kind of draw what's happening. We have a frictionless inclined plane. We have a 40 Newton box, so the weight is 40 Newton. It slides through 10 meters, so the distance it covers is how much? The distance it covers is 10 meters along a frictionless inclined plane, making a 30-degree angle with the horizontal. Calculate the work done on the box by the normal reaction of the incline. The normal reaction is basically the normal force. The normal force, because it is perpendicular. Remember, whenever you face a perpendicular force, then the work done is 0. So, by the normal reaction of the incline, because the normal reaction is perpendicular to the displacement of the box, which is the 10 meters, then the force does no work. So, no work done, or you can put 0, okay? Now, by its weight. By its weight is very important. The weight is not normal. Excuse me. It's not normal to the displacement. Our weight, we can actually separate our weight into two components, into the y component, which is perpendicular, and the x component. The y component, it's gonna turn into what? It's gonna turn into w. Wait, this is 30 degrees over here. So the y component, it's gonna turn into w sine 30 degrees. Or sorry, excuse me, cosine? Yeah, exactly. It's gonna turn into w cosine 30 degrees. So the y component, you should know that the y component in an inclined plane, it turns into w cosine 30 degrees, whereas the x component turns into w sine 30 degrees. Now, what do I have? I have my force, which is w sine 30 degrees, right? And what is the weight? They gave us the weight, it's 14 newtons over here. So my work done, okay, my work I will denote it by capital W. It's equal to the weight, which is 40 newtons, times sine 30 multiplied by what? Multiplied by the displacement, which is 10 times cosine angle. Here in this case, the angle between the force, which is the Wx, and the displacement, it's gonna be 0. Why? Because they are coincide. And so 40 times sine 30 times 10 times cosine 0 on your calculator, you will get an answer of 200 joules, and that's it for question number 1. Question number 2, what does it say? It says an airline passenger is pulling his wheeled suitcase a distance of 60 meters with a 75 Newton force, making an angle of 37 degrees with the horizontal. So we have a horizontal, we have the suitcase, we have a force of 75 newtons, and the degrees is 37 degrees. So what's the equation to find the work done? Part A, they want the work done. The work done, it's gonna be force times distance times cosine theta. So it's gonna be 75 times 60 times cosine 37, which they told us to use it as 0.8. You will get 3.6 times 10 to the power of 3 joules. Okay, that's it for part A. What does it say in part B? It says the suitcase is subjected to a force of friction having a constant magnitude of 60 newtons. So here is my force of friction F. Okay, and here's my displacement. My displacement here, it's 60 meters. They want us to find the work done by the force of friction along the suitcase. Okay, the force done, the work done, it's equal to the force, which we know it's how much? It's 60 newtons, they gave it to us, times the displacement, which is 60 meters, times cosine the angle. The angle from here to here is 180 degrees. So you put it on your calculator and you will get minus 3.6 times 10 to the power of 3 joules. And that's it for question number 2. We'll move on to question number 3. What does it say? A ball of mass 2 kg. So here we have the mass, falls a distance of 5 meters. So this is the distance. What is the work done by gravity on the ball? So, pay attention. If the ball is falling down, then the work done by gravity, is it going? Okay, first of all, before I explain anything, the work done by gravity means that it's always going downwards, towards the center, towards the earth. But the work done by the potential energy, the gravitational potential energy, it's upwards. Okay, this you should keep in mind. When they ask you gravity, or when they ask you GPE, there is a difference, okay? You have to pay attention to this. So if my ball is falling down, then my work done by gravity is positive. If I threw my ball upwards, then my work done by gravity is negative. If they say work done against gravity, then they are referring to GPE, okay? Pay attention, work done against gravity, GPE. Work done against GPE, it's gravity, okay? Here, if my ball is falling downwards, then I'm gonna have a negative work. If I throw my ball upwards, I'm gonna have a positive work. So they want the work done by gravity on the ball. The work done by gravity, it's equal to m GH. Here, let's assume that G is 10, so it's going to be the mass, which is 2, times G, which is 10, times the height, which is 5. So in total, you got 100 joules. Now, they want the work done by gravity on the ball as it's projected vertically upwards through the same distance. Now, here, what's going to happen? Because it's going upwards, the work done by gravity is going to be negative, so it's going to be minus mgh. So minus 2 times 10 times 5. So that's going to be minus 100 joules. Okay, that's it for question number 3. We'll move on to question number 4. What does it say in question number 4? The force acting on a box varies with the position of the box, as illustrated in the graph, whereas the direction of motion of the box remains the same. So this is our force and this is our position, right? What do they want to find? They want us to find the work W done by this force on the box over its entire displacement. Now, pay attention to something very important, right? They want the work done, and they gave me force, and they gave me the position. So the work done, we know it's force times distance times cosine angle. But let's say there's no angle here, right? There's no angle. So it's going to be force times distance, okay? So the work done, it's going to be the area under the graph. So what we need to find is the area under the graph. We can separate this into 2 parts, into a triangle like this, and then into a square. Or you could do it immediately as a trapezoid, all right? But something very important to pay attention to, they mentioned displacement. If they said distance, then you would have to measure in absolute value. You'd have to put the distance values in absolute value. But here they mentioned displacement, so you just need to know, where did I end? Where did I start? Okay? So let's find the area of the graph. So the area of the force position graph will give me the work. So here's a trapezoid. My first base, it's 2. So base 1 is 2. Plus base 2, which is from 0 until 6, that's 6, times the height. Now pay attention to the height. My height is from minus 5 to 0, 0 to 5. So my height is actually, we cannot take the full trapezoid because it's not going to work out. It's a good thing we tried to take it. It's not going to work out. Why? Because I have part lying in the negative sense, which is not going to work, and part lying in the positive sense. So when they are in different senses, you need to separate them, okay? So here I have a small triangle, and here I have a trapezoid. Now I find the area of the small triangle, and I add it to the area of the trapezoid, and you don't put anything in absolute value. So here it's going to be the base, which is how much? Which is 2, times the height, which is minus 5. You keep the values exactly as they are, divided by 2, okay? Then, here you need to find area 2. It's going to be base 1, which is 2, plus base 2, which is from 2 to 6, so 4, times the height, which is 5, divided by 2. So I got area 1 to be minus 5 joules, area 2, to be 15 joules. So in total, all in all, the answer is 10 joules, okay? Question number 5. Now we reached spring. A spring of spring constant. They gave us the value of K and of natural length 50 centimeters. So this is X initial. Remember to always change it to meters. So you need to divide by 100. So 0.5 meters is stretched to a length. So now they stretched it to 0.55 meters, right? So what's gonna be delta x, the change in x? It's gonna be 0.05 meters. Now they want the work done, W, on the spring. When they say work done on the spring, it's gonna be plus 1 over 2kx squared. But then, if they said ever work done by, work done, let me just bring this down, work done by the spring, then you'd have to use minus 1 over 2kx squared, okay? So because they want the work done on the spring, we need to use this. 1 over 2 times k, which is 200, times x. We found x, but here mainly it's not x, it's delta x, because it's the change in length, the extension, right? So it's going to be times 0.05 meters. So you put it on your calculator, 1 over 2 times 200 times 0.05. And don't forget to do something very important, which is to square it. I forgot to put the square. So 1 over 2 times 200 times 0.05 squared, I got an answer of 0.25 joules. And yes, this is the correct answer. Okay, that's it for question number 5. We'll move on to section 4.2, which has question 6 has a grid. A solid box of mass 36 kg, so this is the mass, is sliding in a straight line at 5 meters per second. This is the velocity across a rough horizontal surface. What is the magnitude of work done by friction to bring the box to rest? If you read the title of this section, it is the work energy theorem. What is the work energy theorem? Very simply, it's that the net work done is equal to the change in kinetic energy. So we have a solid box of mass 36 sliding in a straight line at 5 meters per second across a rough horizontal surface. Now, what happens is it brings the box to rest. So this is V final, that's V initial, that's V final. They want the magnitude of work done by friction. Friction is the only force that is exerting work. So the net work done will be the work done by friction. Okay? I always prefer to draw the scenario if you want. So here we have a box. It's 36 kg, so 360 newtons. It's sliding like this, but there's no force here. It's just sliding. The only force acting on it is friction. And don't forget the normal push of the surface, okay? So on the y-axis, they are equal to each other because it's not moving up and down. It's only moving how? It's only moving left and right. That means the only force acting is the friction. If it's being displaced like this, if the displacement is like this, then the work done by friction, it's going to be force times distance times cosine the angle between them, which is 180. So it will end up being minus friction times the distance d. Okay? But we don't really care about this. They didn't ask us for this. They asked us for the magnitude of work done by friction. So what I could do, because they did not give me the distance, so I couldn't solve it that way, what I could do actually is I could substitute in the change in kinetic energy. So it would be 1 over 2 mv final squared minus 1 over 2 mv initial squared. So 1 over 2 times 36 times V final, which was 0 squared, minus 1 over 2 times 36 times 5 squared. You will get an answer of minus 450 joules. So this is the net work done. But they asked for the magnitude, so we need to put this in absolute value to get 450 joules. Okay, that's it for question 6. We'll move on to question 7. 7 has a lot of parts, all right? But we are going to try our best to solve it all. A block of mass 5 kg. So we have from the center of gravity the mass of the block, which is 5 kg. They said use G as 10, so the weight is 50 newtons. It's placed at the point A on top of the inclined plane. That makes an angle of 30 degrees with the horizontal. The block slides down from rest. That means V initial is equal to 0 meters per second and reaches a speed V at the bottom of the incline D. So here we get the box. It comes over here and it has a speed of what? It has a speed of V meters per second. And the total distance covered from here to here, okay, it's how much? It is 2 meters. So they want us to draw the free body diagram. So let's draw the free body diagram. First of all, hold on, let me move my taskbar. First of all, just remember to draw your x and y axis. Here was my initial block, right? Here's the weight of the block. We have the normal push of the block as well, and these are the only forces acting. And then, they want us to include the direction of the displacement in the free body diagram. So the direction of the displacement is like this. Okay, this force is the weight, so you can say mg, and this force is n, the normal push over here. Okay, so that's part A done. Part B, what does it say? It says find the work done by each force in terms of distance D equals to AP. Let me as well add the normal push. Okay, I call this N. And this is the weight. The work done by the normal push, because it's perpendicular to the displacement, immediately it is 0. The work done by the weight or gravity. So you can say WW or WMG. What is it gonna be? First things first, we need to resolve what we're dealing with, okay? So I cannot stand to look at my weight like this. I need to resolve it. So I'll resolve it into two forces, into my y-axis force, my y-axis weight, and my x-axis weight. On my y-axis, it turns into W cosine 30. On my x-axis, it's W sine 30. So here it's gonna be 50 sine 30. So here it's 25 newtons. And here it's what? Here it is 25 cosine 30, so that's gonna be almost 22 newtons. Okay, so the work done, let's say the work done by W on the y-axis is 0. Why? Because it is perpendicular to the direction of motion, so it's not gonna yield anything. But now the work done by the W on the x-axis, it's gonna be the force, which is 25 newtons, times the distance, which is 2 meters, times cosine the angle between 25 and 2 meters. They are both parallel to each other, so the angle is what? The angle is 0. Okay, so I will end up with what? Actually, they didn't specify the distance. Excuse me, that's my mistake. They didn't specify the distance, so it will turn out to be 25 times d times cosine 0. Cosine 0 is 1, so it's basically 25d. Okay. Part C, what did they say? They said, apply the work energy theorem to determine the kinetic energy of the block at point P. Oh, so we don't know the distance at point P. Okay. So, excuse me, I didn't read it. I thought they were talking from A to D. No, they're talking from A to P. So we don't know the distance. That's why we called it D. Now let's use the work energy theorem. Here, it starts initially at rest. Here, it has a velocity that we're going to call it velocity P, for example. Okay, so what would the work energy theory be? First of all, it's the change in kinetic energy is equal to what? It's equal to the network done. The network done from A to P, we found it to be 25d. So 25d is equal to the change in kinetic energy. So it's usually kinetic energy final minus kinetic energy initial. There's not going to be kinetic energy initial. Why? Because V0 is 0. So it's just going to be kinetic energy final, which we will call it Kp. So we can keep it like this, that 25d is equal to Kp. Okay. We'll move on now to part D. It says deduce the speed V of the block at the bottom of the incline. So here we can also apply the work energy theorem. Here again, it's also going to be the kinetic energy. Excuse me, I think I moved up. Let me move it up. Okay. It's going to be the kinetic energy at point D minus the kinetic energy at point A, which is 0. It's equal to what? It's equal to the force, which is 25, times the distance from A to D, which is 2, times cosine 0. So I got KD to be what? I got KD to be 25 times 2, which is how much? Which is 50 joules. Now, KD, it's what? It's 1 over 2 mass of the block times VD squared. The mass of the block is how much? It's 5 kg. So you'll move this to the other side. You'll get that VD squared is equal to 2 times 50. So that's gonna be 50 times 2, that's 100 divided by 5, that's 20. So VD squared is gonna be equal to 20. So VD is equal to radical 20. What's radical 20? It's 4.47 meters per second. That's VD very simply. Part E, what does it say? It says a sensor measures the speed of the block at D and shows that it's equal to 3.4 meters per second. One interpretation for the discrepancy between the real speed and the one you calculated is that the incline is not perfectly frictionless. That means there is a bit of friction. Now they're saying find the work done by friction between A and D. Now this is smart. Again, we need to use the work energy theorem. What happens is we can find that the kinetic energy over here minus the kinetic energy that they got over here. Okay, but you need to remember that the work done by friction is always negative. So actually, you know what, in this case, we would take this one as the final one and this one as the initial one. So kinetic energy final minus kinetic energy initial. So it's going to be 1 over 2, the mass, which is 5, times 3.4 squared, minus 1 over 2 times 5 times 4.47 squared. Okay, you will get an approximate answer of minus 21.1 joules. Okay, so that's it for question E, part 1. Now part 2, they said deduce the coefficient of friction, mu, okay? You should know that friction, it's equal to the normal push multiplied by mu. The friction, so mu is equal to the force divided by the normal push. The normal push, it's equal to what? It's equal to, let's make it better. It's equal to the weight, Wy, which is W cosine theta, which is 30 degrees, right? And I know that my force F, it's equal to what? It's equal to the work done by friction divided by the distance, because force F times distance is the work done by friction. So what I will end up with is the work done by friction divided by the distance. All of it divided by what? Divided by the weight, which is 50 times cosine 30. So then if you fix it up, you will get that the work done by friction divided by the 50 cosine 30. So the work done by friction is what? Is minus 21.1. And then the distance is what? The distance is 2 meters. So on your calculator, minus 21.1 over 50 times 2 times cosine 30, you will get the coefficient of friction to be 0.24, and there is no unit. That's it for question number 7. We'll move on to section 4.3, which is the potential energy. The gravitational potential energy. Remember what we said, gravitational potential energy. The higher up you go, the more positive. The lower you go, the negative, of course, with respect to the reference point. Okay, so the gravitational potential energy, GPE of an 800 grams, so 0.8 kg bird, relative to the ground is 25 joules. Okay, so they gave us G. They want us to find the height of the bird above the ground. So we know that GPE, the work done by it, is mgh, and because it's up above the ground, then it's going to be plus mgh. So it's going to be 0.8 times 9.8 times the height, right? It's equal to what? It's equal to 25. So then I'll move this to the other side. I got the height to be 3.2 meters. Okay, that's it for question 8. We'll now move on to question 9. What does it say? Very simply, a string of force constant 250 Newton per meter. So this is the force constant K. Stores this much energy. This is the energy, okay? What is the extension of the spring? You should know that the energy is the same as the work done. It's 1 over 2 kx squared. So 0.10 is equal to 1 over 2 times 250 times x squared, right? So then x, it's going to be equal to what? X, let's do x squared first. It's going to be 0.10 times 1 over 2, not times, divided by, because we're bringing it to the other side, and open your brackets. Divided by half times 250, I got 8 times 10 to the power of minus 4, right? Now, what do I need to do? I need to do radical for both sides. So, I will end up with x being 0.028 meters. So, you can keep it in meters and you can change it to centimeters however you like. So, it will turn out to be 2.8 centimeters, okay? We move on now to question 10. What does it say? What does it say in question number 10? A box of mass 5 kg is pushed up an inclined plane. So, let's draw what we're dealing with. We have 30 degrees inclined plane, and we have a box of mass 5 kg. They gave us G to be 10, so the weight is 50 newtons. It's being pushed up, and the distance covered was how much? The distance covered was 3 meters. They want the work done by gravity on the box. This is a very easy, simple question. You can do this in many ways, but my personal favorite is to use the MGH method. Now, because it's going up, right? It's going up the inclined plane, right? So we're going to have negative mgh. So we have our weight to be 50. We have the total displacement to be 3 meters, but we don't want the displacement. We need the height. So if this, let's say all of this was 3 meters, all of this was my displacement of 3 meters, then how do I get the height? I need to apply sine rule. So 3 meters is my hypotenuse. I have 30 degrees, which is my angle, and then I need to find the height which is opposite to it. So I need to do 3 times sine 30. I got my height to be 1.5 meters. So it's gonna be minus mgh. Mg is basically the weight, so it's gonna be minus 50 times 1.5. So basically it's gonna be minus 75 joules. Okay, we'll move on now to part B. Calculate the change in gravitational potential energy of the box. Basically, the change in gravitational potential energy of the box is the opposite of the work done by the gravity. So, what you need to know, the change in potential energy, so GPE, okay? It's equal to minus the work done by gravity. Very, very, very simply, they're opposites to each other. So, that means this would be plus 75 joules, okay? We now move on to question 11. What does it say? It says a book of mass 0.50 kg is lowered from a 60 centimeter. So this is actually, we need to change it to meters. So we divide by 100 to get 0.6 meters. High desktop to the floor as shown below. What are the initial and final gravitational potential energies of the book if the desktop is taken as the zero potential? So let's find the initial potential energy. GPE, right? Initial. Because they took the desktop as the reference, then directly on the reference, my height is 0, so my GPE is 0. GPE final, it's what? It's gonna be my mass mgh, but because it's going under my reference point, it's gonna be minus mgh. So minus the mass, which is 0.50, times g, which is 10, times the height, which is 0.6. So then I got an answer of minus 3 joules, and that's it for question 11. We'll move on now to question 12. What does it say? So, graph the variation of the elastic potential energy stored in a spring versus its elongation. You need to know it's an exponential function, right? my potential energy here in joules, my displacement here, x in meters, it's gonna be an exponential function like this. Why? Because I have my potential energy. It's equal to 1 over 2k x squared. Because of the x squared, it has what? It has an exponential function, an exponential rise. Okay, so that's it for question 12. We'll move on to question 13. A block is pulled along a rough horizontal floor by means of a string. The block moves through a distance. Categorize the forces acting on the block as conservative or non-conservative forces. So what is the definition of a conservative force and a non-conservative force? A conservative force is conservative if the work is done and it depends on, actually no, it does not depend, excuse me. A conservative force, I don't know how to explain it, let me rephrase my words. A conservative force is conservative if the work it does not depend on the path taken, it only depends on the initial point and the final point. But a non-conservative force depends on the path taken. So, for example, when they say the work done around a complete closed path, it's gonna be 0. The work done along a straight line, it starts at a point and it ends at a point, right? So basically, that's just like the general definition of conservative and non-conservative forces. Additionally, for conservative forces, you can define potential energy. For example, I'll give you examples of conservative forces. We have the gravitational force, we have the spring force, and we have the electrostatic force. These are 3 important examples. Gravitational force, you say gravitational potential energy, okay? You can define it as something potential. Spring force, elastic potential energy, you can define it as something potential. Electrostatic force, it's electric potential energy, you can define it as something with potential energy. So a hint in the exam, if you get something that you can define with potential energy, then it is what? It is a conservative force. Otherwise, it's a non-conservative force. Examples of non-conservative are friction, air resistance, viscous forces. Now, there is an example, the normal push. It's usually classified as the non-conservative force. In general, the normal force it's not fixed with potential energy, right? But because it usually does 0 work, we don't really care about it. But just in general, it's what? It is a non-conservative force, okay? So anyways, we have a box on a rough horizontal floor. By means of a string, what's it doing? It's pulling the box. Okay, so we have a tension. Of course, we have the weight and we have the normal push. Of course, we have the friction as well. Okay, so now I need to think which of the following can be classified as potential. Normal cannot, so this is a, sorry, excuse me, I'm using the wrong pen. So this is a non-conservative force. Friction cannot, so non-conservative. Tension cannot, non-conservative. But weight, we can say weight or gravitational potential energy, so gravity, GPE. So yes, then it is what? A conservative force. So that's it for question 13. We move on now to question 14, the last 3 questions. Not the last 3, actually, there's 1 more question, and that's it. 4 more questions, we finish chapter 4. So, question number 14. A pendulum consists of a small sphere, a bob. So let's try to draw what they are explaining to us. It consists of a small sphere, a bob, tied to a 1-meter string and suspended from a ceiling. Okay, so the string has a length of how much? Of 1 meter. The pendulum is displaced to the side. Oh, so excuse me, let me draw it normally. So it's like this, it has a length of 1 meter. The pendulum is displaced to the side so that the bob is 0. Okay, so look what happens. The pendulum is displaced like this. So now, what's the height difference? It's 0.050 meters above its initial position. The pendulum is then released from rest. What is the greatest speed that the bob obtains? The greatest speed that the bob obtains would be over here. Because look, here, the greatest kinetic energy, that means the greatest speed. Here, for example, it has the greatest potential energy. Here, for example, it has the greatest potential energy. So let me find at its original position what was its speed. This would be what? This would be the greatest speed. Now here, I need to apply the law of mechanical energy, the rules of conservation of mechanical energy. Mechanical energy initial is equal to mechanical energy final. So I need to think of the original diagram, this, right? Initially, what did I have? I had this over here, right? I have that the height is 0.05 meters and that Actually, let's do it like this. Mechanical energy initial, U1, which is potential energy, plus K1 equals U2 plus K2. Initially, it was released from an S. That means it did not have any kinetic energy, right? And then U2, because it's coming here, this is at the original position, so the from the reference point, the height is going to be 0, so we're not going to have any potential energy. So then we can say that U1 is equal to K2. So what does this mean? This means that mgh, it's going to be equal to what? Mgh, it's going to be equal to 1 over 2 mv squared. We don't have the mass, but the mass cancels. They want the speed. So v, it's equal to what? It's equal to radical 2gh, right? So it's going to be what? It's going to be radical 2 times 9.8 times the height, which is 0.05. So I got, excuse me, I got a maximum speed of 0.99 meters per second. That's it for question 14. Question 15. A tennis ball is thrown from the roof of a 25-meter high building with an initial speed of 15 meters per second. So we have the height, we have v initial, directly downwards. Okay, what is the speed of the ball just before it strikes the ground? Here we again need to use mechanical energy. Mechanical energy initial equals mechanical energy final. U1 plus K1 equals U2 plus K2. Initially, it had mgh, okay, mgh1 plus 1 over 2 mv initial squared. It's equal to u2, so here it's at the ground, so at the reference point, so we're going to say that u2 is 0, so it's gone bye-bye, plus 1 over 2 mv final squared. So they did not give us the mass of the tennis ball, but here we can take it out and it will cancel. So here this cancels, and this cancels. So now I have gh1 plus 1 over 2 v0 squared. It's equal to what? It's equal to 1 over 2 v final squared. So substitute the values. What is gg is 10. 10 times 25 is equal to 1 over 2, plus 1 over 2 times 15 squared is equal to 1 over 2 times the v final squared, which we need to find. So then you move 1 over 2 to the other side. It turns into 2 times, open brackets, 10 times 25 plus 1 over 2 times 15 squared. Close the brackets, you will get 725. Do a radical answer. I got v final, my final velocity, to be, let me just check my answer. Yes, it's correct, to be 26.9 meters per second. That's it for question 15. We'll move on to question number 16. What does it say? A 3 kg block is released with an initial velocity of 5 meters per second. So v0 equals this. This is the mass. From the top of an inclined plane, whose shape is shown below. The inclined plane is 2 meters high and is considered frictionless, right? The block reaches the point B with a speed of vb. So here it has a speed of vb. It continues moving on a horizontal stretch whose coefficient of friction, so now we have friction over here, is 0.35. The block comes to a complete stop after traveling a distance d along the rough horizontal surface BC. Use g equals 10 meters per second squared. So let's start with part A. Determine the speed of the ball at point B. This is the easiest part. It's very simply, we're applying mechanical energy. We are changing from where to where? We're changing from A to B, right? So it's released from, not rest, it has an initial velocity. So we have to apply mechanical energy initial equals mechanical energy final. So U1 plus K1 equals U2 plus K2. So here, this is the only thing that will disappear. So it turns into mgh1 plus 1 over 2 mv initial squared is equal to 1 over 2 mv final squared. So v final squared, which is vb, it's equal to 2 times. What is the mass? The mass is 3 times. You could cancel the mass actually. There is no point in adding the mass, so you can cancel it out. So it's going to be 2 times the g, which is 10, times the height, which is 2 meters, plus 1 over 2 times 5 squared, okay? Put it on your calculator. So, anyways, I got 2 times 10, and don't forget to open your brackets, 2 times 10 times 2, plus 1 over 2 times 5 squared. Please do not forget your brackets, that's very important. So I got v squared is 65, radical answer. So I got v final or vb, it's 8.06 meters per second. Now part B, they said find the distance. So now in part B, it's saying find the distance d covered by the ball using 2 methods. The first method would be to use the work energy theorem. So the net work is equal to the change in kinetic energy. So here it has a speed of what? What did we find the speed to be? 8.06. And then it ends up to stop. So the speed becomes 0. So the net work done by friction in this case, it would be the force times the distance covered. So the force of friction times the distance covered, multiplied by what? Multiplied by cosine the angle. So friction works like this. The ball is moving like this, and it's having a displacement like this. So it's going to be the angle 180 degrees, so just minus 1. So minus friction times distance is equal to the change in kinetic energy. So it's basically going to be minus 1 over 2. The mass, right? Which is 3 kg, times the velocity squared, which is 8.06 squared. My frictional force, it's my normal force times mu. Here my normal force is basically the weight of the ball, so it's gonna be mg mu. So it's gonna be minus 3 times 10 times mu, which is 0.35, times the distance d is equal to whatever that is. So then d, it's gonna be equal to what? It's gonna be equal to minus half times 3 times 8.06 squared, okay, divided by minus 3 times 10 times 0.35. So then you get, so, okay, basically I'll move this to the other side. So minus 1 over 2 times 3 times 8.06 squared, divided by minus 3 times 10 times 0.85. I got the distance d to be 9.3 meters. Now, the second way, you can use sigma F equals ma. So the only force acting is the friction. Friction is equal to mass times acceleration. The acceleration here, it's going to be v final minus v initial over... Oh, actually, no need to do this. We can find the acceleration directly. We know that the frictional force, it's normal push times mu. Normal push, when the ball, it's here, it's the same as the weight. So it's going to be mg mu. It's equal to ma. So acceleration is g mu. So acceleration, it's equal to 10 times 0.35. So it's 3.5 meters per second squared. Now, what do? I need to use this equation. V final squared minus V initial squared equals 2a delta x. Delta x is the distance d. So what's V final squared? 0 squared minus 8.06 squared is equal to 2 times 3.5. But pay attention to something very important. I forgot to add, and I forgot to mention that it's minus friction, so it's minus gm. Why? Because it's decreasing the speed from 8.06 to 0, so it's decelerating. So my acceleration should be what? Should be negative, right? So it's not going to be 2 times 3.5, it's going to be 2 times minus 3.5 times the distance d. So basically I got minus 8.06 squared divided by 2 times minus 3.5, and I got an answer which is exactly 9.3 meters, okay? So that's it for question number 16. So we skip 17, 18. Now we have 19, 20, and 21. So now we'll move on to 4.6, where we have questions 19, 20, and 21 only. So question 19, an electric generator consumes this much energy, out of which 75 kilojoules is wasted. What's the efficiency of the generator? How do you find efficiency? Efficiency, very simply, it's gonna be what? It's gonna be the used energy over the total energy, of course, times 100%. Since 75 is wasted, that means only 25 is used. So it's going to be 25 that were used over the 100 total times 100. This will give us 25% as an answer. This is the efficiency of the generator. 26, grid. A motor lifts 40 kg. This is the mass. Load by 2 meters. This is the distance. This is the time. They gave us g. This is not, the distance, this is the height. What is the power output? To find the power, it's going to be work divided by time. The work in this case is mgh because he's being lifted up, divided by the time. So 40 times 9.8 times 2 divided by 5, that's 157 watts. And then last but not least, question 21. Consider an object of constant power. Very important. Graph roughly the variation of the net force acting on the object with its speed. Okay, here, this is used to explain that power is equal to force times velocity. You can also find the power by doing force times velocity. If you drew the graph, it would look something like this. They want force, speed, or velocity graph. Since they are on the same side of the equation, they're not directly proportional, they're inversely proportional, so their graph would look like this, okay? So that is it for chapter 4. Thank you guys for watching, and see you in the next chapter, which is chapter 5. Hello guys, how are you doing? So this is the last video for the part A. This is the last chapter we have for part A, which is chapter 5. We have sections, let me check, 5.1, 5.2, and 5.4. So I'm not going to be doing any top questions except for the only top question in 5.4, okay? So let's get ahead. Let's start with section 5.1, question 1. What is the speed, v, of a vehicle of mass 500 kg whose momentum is 4.0 times 10 to the power of 3? Now, you should know that momentum, denoted by p, is equal to the mass times the velocity. Don't confuse this small p for capital P, which is power. Power is force times velocity. But small p, which is momentum, is mass times velocity. So they want the speed, we have the mass, we have the momentum. So speed v, it's equal to the momentum over the mass. So it's going to be 4.0 times 10 to the power of 3 over 500. So that's going to be 8 meters per second. That's it for question 1. We'll now move on to question 2. A ball of mass 0.15 kg and moving at 5 meters per second undergoes a perfectly elastic collision with a wall. So mass how much? 15 kg. Moving initially 5 meters per second. It undergoes a perfectly elastic collision. What does perfectly elastic mean and perfectly inelastic mean? When they say perfectly elastic, so this was the ball, it was flying and it hit, and it rebounds at the exact same speed without losing any of its kinetic energy. Now, notice how I said it rebounds with the same speed, not the same velocity though, because they're going in opposite directions, alright? So basically, before I continue, let's get you familiar with the inelastic and elastic collision. Basically, let's compare elastic and inelastic collision. Momentum is conserved in both elastic and inelastic, but kinetic energy is only conserved in elastic collision. In inelastic collision, it's not conserved. Now, the objects do not usually stick together in elastic collision, and if it's perfectly inelastic, then it sticks in the inelastic collision. And there is no heat that's there's no energy that's converted in elastic collision, but there is energy in an elastic collision that is converted. Why? Because the kinetic energy is not conserved. So, because we have our ball, it bounces and it rebounds elastically, it has the same exact speed. They're asking, what is the average force exerted by the wall on the ball? How do we find this? We have our mass, okay? We can find the change in velocity. Mass times change in the velocity is the momentum. Now, the momentum, it's also equal to what? Momentum, it's also equal to the force times the change in time. All right, so I have the mass, I have my initial velocity, and I find my final velocity because it rebounds inelastically. So it's gonna be -5, right? Because it bounces back in the same magnitude but different direction, opposite direction. We have the time over here, so they want the average force here. I can imagine this does not exist. So m delta v equals f delta t. So F is equal to the mass, which is 0.15, times delta V, which is basically V final minus V initial minus 5, divided by the change in time, which is 0.20. Now, usually they want, when they say average force, you need to put your answer in absolute value. So whatever answer I got -7.5, I put it in absolute value, so my answer is 7.5 newtons, okay? We'll move on to question number 3. What does it say in question number 3? A tennis ball of mass 60 grams, so it's actually 0.060 kilograms, is shot with a speed of 24 meters per second. This is V initial, toward the wall and rebounds in the opposite direction with exactly same speed. So V final is -24 meters per second. Alright, actually they said the same speed, but it goes in the opposite direction, so V final is -24. The diagram below shows the variation of force exerted by the wall on the ball with respect to time. Okay, so we can apply an equation. Actually, I might have stated the previous equation wrongly. The momentum is denoted by P. The impulse, which is the change in momentum, delta P, it's denoted by what? It's denoted by J. So M delta V, it's not P, it's J. MV is P, which is momentum, but the impulse, it's J, alright? So, which is M delta V. So J, the impulse, is M delta V. So we have the mass, which is 0.060, times the change in speed, so -24. You know what they're doing actually? They're taking the initial direction to be negative. So if this was -24, then this would be +24. So then it's 24 minus -24. So then you have 0.06 times 48, which will give you an answer of 2.88 kg times meter per second. Okay, this is the impulse unit. Now, another way you could do it is by saying that the impulse is equal to the force times the change in time, right? Now, force, we know it's the mass times the acceleration, but which force are we dealing with? It's very important to notice that we're not dealing with the maximum force, we're dealing with the average force. So how do you find the average force? You need to find the mass times the average acceleration times the change in time, of course. Now, we know that the average acceleration is equal to the change in velocity divided by the change in time, right? So it would be what? It would be 24 minus 24 divided by 6 times 10 to the power of minus 3. How did I know the time? I look at my graph. I start 0, I end at 6 milliseconds, which is 6 times 10 to the minus 3 seconds. So I will get 8,000 meters per second squared. So this is the acceleration. So now the impulse, J, it's gonna be 0.06 times 8,000 times what? Times the change in time, which is 6 times 10 to the power of minus 3. So I got it to be 2.88 kg times meter per second. Okay, that's it for 4.1. I'm not gonna do any of the top questions, but I will move on now to 4.2. What does it say in, sorry, not 4, sorry, 5. So 5.1, and now move on to 5.2. It only has one question. Two carts of masses m1 equal m and m2 equal to m move towards each other. So we have our first cart. It has a mass of m. We have our second cart over here. It has a mass of 2m. They are moving towards each other at, here this is v1 equal to 5 meters per second, and here this is v2 equal to 6 meters per second. But because they're going in opposite directions, one of them needs to be negative. So I would choose, for example, this to be minus 6 meters per second, okay? The cars collide, and the lighter cart, okay, so at some point they collide, they meet, and they like bump into each other. And the lighter cart, which is the m1, rebounds. That means it goes in the opposite direction at a speed. So let's call this, okay, if this is u, then this would be v. So this would be v1. v1, it would be 3 meters per second, but it's going in the opposite direction, so minus 3 meters per second. Now they want us to find the velocity of the other cart. Here we need to apply the conservation of momentum, which is that momentum initial is equal to momentum final. So let's do that. We need to find the momentum for both bodies. So for the first body, it's gonna be the mass times the speed. So m times u1 plus 2m times u2. It must be equal to what? It must be equal to m times v1 plus plus 2m times v2. Now we substitute our values, right? So here it's gonna be m times 5 plus 2m times minus 6. It's equal to m times minus 3 plus 2m times v2. Now all of them have m as a common factor, so we can cancel out the m. So now we have 5 plus 2 times minus 6 is equal to minus 3 plus 2v2. So basically this is 5 minus 5, that's minus 7. It's equal to what? Excuse me, I accidentally stopped my video. So I get minus 7, because if I remember correctly, it was 5 minus 2 times 6, or plus 6 times minus, plus 2 times minus 6 is equal to m times minus 3 plus 2, is equal to minus 3 plus 2 v2. And please ignore that I went all the way to the bottom. So then anyways, it's gonna be minus 7 is equal to minus 3 plus 2v2. You move this to the other side, and I got minus 4 is equal to 2v2. So v2 is then equal to minus 4 meters per second, okay? So the speed, I forgot which page it was. Let's go back to find it. Okay, here's torque. Let's go all the way here. Yeah, here. Here's 5.4. Okay, so the velocity of the heavier cart, we found it to be minus 4 meters per second. The magnitude is 4 meters per second, and the direction is the same as how it was initially moving. Okay, because it started as minus 6, it's still minus 4, so they're both in the end moving in the same direction. So now we'll move on to question 8 and 9 and 10. This is the only top question I'll be doing. Okay. So let's move on to 8. Two particles of masses 200 grams, so 0.2 kg, and 0.8 kg undergo a head-on perfectly inelastic collision. What does inelastic mean? That means that kinetic energy is not conserved. All right, there's still conservation of momentum, but it's not conserved. And on top of that, the two particles will stick together. They will coalesce. before collision, let's draw what's happening. We have, for example, the 0.2 kg. It's moving towards the 0.8 kg, and the 0.8 kg is moving towards the 0.2 kg. Both of them are at 10 meters per second. So if that's 10 meters per second, the other is at minus because they're both going towards each other. Now, what's their speed after collision? Here we need to find it. So they will collide and they will form one body of combined mass 1 kg. Okay? Now we need to find the speed and the direction of this. So we'll apply m1 u1 plus m2 u2 is equal to m total times v total, because they coalesce, because it is an elastic collision. Okay, so it's gonna be 0.2 times 10 plus 0.8 times minus 10 is equal to 1 times v total. So 2 minus 8, that's gonna be minus 6 is equal to 1 times v total. So I got v total to be minus 6 meters per second. So it would be moving in this direction, minus 6 meters per second. So what are they looking for? They're looking for their speed after the collision. We cannot say minus 6. We take the velocity, we put it in absolute value. So it's gonna be 6 meters per second, okay? That's it for question number 8. We'll move on to question number 9. What does it say? Molecules of an isolated gas undergo constant random motion. However, the total kinetic energy of the molecules do not change over time. When the total kinetic energy does not change, you will say that this has elastic collision. This is a very important theory, the gas theory, or like the law of gases in chemistry, that gas particles, ideal gas particles, they have perfectly elastic collisions, okay? So anyways, that's it for question 9. Let's move on to question 10. What does it say? Define a force. Okay, this is very important. When they ask you to define a force, you should say that the force is the measure of interaction between two objects. In the answer key, this is what it says. To define a force, it's the measure of interaction between two objects. That's it, and done. Now look what they told us. They told us that block A slides along the horizontal frictionless surface towards a stationary block Y. Block X goes to block Y, as shown in the diagram below. The initial linear momentum of the block X is 1.2 kg times meter per second. So we have both masses identical and they're equal to 800 grams. So this is 0.8 kg, this is 0.8 kg. This is moving with an initial momentum of 1.2 kg times meter per second. So we can find the initial speed, right? And this is stationary, right? The variation of momentum of the block Y with time is shown in the diagram below. So initially it had 0 momentum, but then at 2 seconds, suddenly it had an increasing amount of momentum. And then it stopped at a constant momentum, which was 3.5 kg times meter per second. Part B says, what aspect of the graph suggests that the force exerted by block X on block Y during the collision is constant? Very simply, we go back to the moment of collision, which is over here, when the second block Y gains the impulse, right? If you look at this slope over here, right? The slope of the graph corresponding to the collision, it's a constant, right? It has a constant value. It's a linear line, right? So basically we can say that the slope of the graph is proportional to the acceleration of block Y, and very simply we know, according to F equals ma, that the acceleration is directly proportional to the net force on block Y. So then we can say that the force exerted by the block X on block Y is constant. Why? Because the momentum or the slope of the graph was constant. Actually, another way of taking it is the slope of the graph is momentum divided by time. Change in momentum divided by time. So impulse divided by time. Impulse divided by time is the force, the average force, alright? So that's pretty much it for part B. For part C, what does it say? It says calculate the force exerted by the block X on the block Y during the collision. Here we can use the idea of it being a slope. So here I see that this is 3.5 and here this is 0. And what's my time here? My time here was 2.5 and my time here was 2. So now it's gonna be y minus y over x minus x. This is 2.5, 3.5, and this is 2, 0. Okay, so now you're gonna subtract them. 3.5 minus 0 over 2.5 minus 2. So I will get 3.5 over 0.5, which is 7 newtons. Okay, now for the last and final part of the question, calculate the speed of block X after the collision. By the conservation of momentum, we need to apply this. We need to apply m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. Now, for block Y, it was constant, so it does not have an a momentum initially, right? So it's just gonna be m1 v1, and they already gave us the impulse, which is 1.2, okay? It's equal to what? It's equal to the mass of block 1, which is, excuse me, let me interrupt just to go back down and see. They want the speed of the block x after the collision, yeah. So, okay, so anyways, again, as I was saying, m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. Here we know this is 0 because it was initially stationary. Here they gave it to us, it's 1.2. We can get this from the graph, so this is 3.5, right? And then what's left for us is m1 times v1. I believe the answer key might be wrong. So it's gonna be the mass of block x, which is 0.8 times the speed v1. So I'm gonna move 3.5 to the other side. So 1.2 minus 3.5, I got minus 2.3. Minus 2.3 divided by 0.8, I got, oh no, they did the same exact method as me. But I got my velocity x to be what? My velocity x to be minus 2.9 meters per second. However, they asked for the speed, so what do I need to do? I need to put it in absolute value, and I will say that the speed of block x after the collision, it was what? It was 2.9 meters per second. If they asked me the velocity, I say minus 2.9. If they ask the direction, you say that it bounces backwards or it rebounds. Okay, that's it for chapter 5, I believe. Thank you guys for watching. I hope you enjoyed and have a wonderful day. That's it for mechanics part A.